Good morning, everyone. It's a great pleasure to be opening this day of academic sessions. And it's also a great pleasure to see so many people here also today. Yesterday, Hugh Pill emphasized the importance and usefulness of granular data during exceptional times, because it's difficult to make reliable forecasts on historical data. And the following presentation is now a good example of a paper that uses Swedish microdata to better understand inflation at its source, the price-setting firm. Please welcome Peter Tillman from the University of Gießen to the stage and present the first paper of this day.
All right, thanks very much for this kind introduction. Thank you very much for having me. It's a great pleasure to be here. This is a joint paper with two co-authors, both from central banks, Matthias and David, so I need to mention the usual disclaimer here. So what we do in this paper, as you said, is, well, we look at the consequences of global supply chain disruptions for inflation. And to study that, we pick one country, which is probably a typical small open economy, and also a country for which we have excellent access to microdata. So the contribution here is twofold. First, we identify a global supply chain disruption, and second, we look at how different firms at the micro level respond to the same supply chain shock. So throughout my presentation, I will jump a bit back and forth between micro and macro data, but that's essentially our approach. We use macro data to identify the global supply shock, and then we look at the micro responses. Well, obviously, you know that global supply chains have been, well, a side effect, or have been one aspect of globalization over the past couple of years. But of course, these supply chains, while in normal times being a source of efficiency, can be in crisis times a transmission channel of all sorts of disruptions. And we have seen lots of these disruptions. We have seen natural disasters. We have seen COVID. I will come back to that. And currently, we see geopolitics. And therefore, global supply chain bottlenecks are considered one of the drivers or one of the reasons for the surge in inflation, which we have seen 2 or 3 years ago. So in this paper, we look at the effects, and we want to quantify the effect of supply chain disruptions for the Swedish economy. This is the type of news that we had in mind when starting this project. Well, here you see a very export-oriented Swedish company, and as the headline says, well, they raise prices because of global supply chains. Now, we proceed in 4 steps. Let me quickly mention these 4 steps. First of all, we start from the macro level. We identify a global supply chain disruption, and we do that based on a VAR, which is a standard macroeconomic tool, using, I think, a new sort of restrictions, which in the end give us a time series of supply chain shocks. We then look at microdata, and it's essentially the entire data set that underlines the Swedish producer price index. And then we look at, well, how does this one global supply chain shock drive producer prices at the product level? And we distinguish between firms. So we can say, well, firms with high inventory holdings versus firms with low inventory holdings, which is probably a good candidate for explaining cross-firm differences in the responses to the same shock. Well, what do we find? Well, we find that global supply chains cause indeed a significant and also persistent increase in producer prices. So roughly, we have a one-to-one effect. We have a 1 standard deviation increase in the supply chain pressure. That gives us about a 1% increase, 1 percentage increase in prices. And we see that this is relatively heterogeneous across firms. We will differentiate between firms along the lines of inventory holdings, size, market power, and all sorts of other properties of firms. Now, let me quickly mention the microdata. We use 3 sources of data for Sweden. We use the data underlying the Swedish producer price index, which gives us price data at the product level. which is data set number 1. Data set number 2 is we use data for industrial production of Sweden. Well, we need that in order to have for each firm sales in particular. And also for each firm, we need to construct something like an exposure to global supply chains. So we want to measure how strongly does an individual firm rely on supply chains. And for that, we construct something which we call the firm-specific export intensity. So we ask how export-intensive is the given firm, and we take that as a measure of how strongly each firm relies on supply chains. Essentially, it's like a treatment effect in the end in our empirical framework. And thirdly, we use balance sheet data. That is, well, the 2 previous data sets are monthly. The third one is annual. We need balance sheet data in order to distinguish firms of different characteristics, for example, large and small firms. Now, this is this export intensity, which I mentioned. So this, again, measures how strongly each firm relies on supply chains. This is the distribution of this across all Swedish firms. And, well, we see on the left-hand side for all firms, on the right-hand side, if we exclude the firms with a 0, essentially it's fairly equally distributed. So we have very export-intensive firms, firms with almost no export orientation, and everything in between. Right? So that is, I think, good news for us. So we really capture the entire distribution of Swedish firms. Now let me turn to the macro side. As I said, we need a supply chain shock. Well, this is, but the emphasis is on shock, so we need to identify the surprise change in supply chain conditions. How do we do that? Well, we use data on container trade, on international container trade. In particular, we estimate a VAR model that includes 6 variables. Well, 3 of them are completely standard Swedish macro time series: industrial production, CPI, import prices. That's not the innovative part. The new part is the second set of variables, which come from international container trade. So we have the number of containers, we have the price index for international container trade, and we have this GSCPI, that's the global supply chain pressure index that comes from the Federal Reserve Bank of New York. So we need these 3 in order to identify a shock. And in the following, I want to explain briefly how we identify this global supply chain disruption based on this set of macro data. We use a combination of sign restrictions and narrative restrictions. So let me explain first the sign restriction, and then I turn to the narrative restrictions, and I explain the narrative restrictions in pictures because that's probably very easy to understand. First of all, we need sign restrictions. These sign restrictions make sure that the shock we are going to identify is indeed coming from the supply side. It's a supply side shock because we assume that the prices for containers and the quantity of containers go in opposite direction. Right? That guarantees that it is indeed a supply side disruption and not accidentally a demand side disruption. Right? So we require that our shock drives up container prices and reduces the amount of containers shipped over the ocean. And to make sure that, well, this is just for consistency, we don't really need it, but we also require that this global supply chain pressure index increases as a consequence of the shock. Importantly, we do not impose any restriction on the macro time series, right? They are entirely unrestricted. So that's identification part 1. Identification part 2 is narrative restrictions. The idea is the following. We want to make sure that our shock is consistent with the established narrative about certain episodes. In other words, we pick 3 episodes and we force the model to have a positive shock, i.e. a restrictive shock, in these 3 episodes. Okay? The first is, well, the Tohoku earthquake. In Europe, it's probably better known as the Fukushima earthquake. So this is the earthquake off the Japanese east coast in 2011. We forced the model to have a positive shock in this very month. Positive means restrictive, right? Second event, well, you remember that. That's where the Suez Canal was blocked for a bit more than a week. We also require the model to have a positive shock, i.e. to be restrictive, in this month. And finally, we restrict the model to be restrictive when the authorities in Shanghai closed the port of Shanghai in order to fight the pandemic. Right? So to give you an overview, these are the restrictions. First of all, the supply shock is positive in March 2011. Second, in March 2011, and I think this is also fairly uncontroversial, the global supply chain shock in this month is the largest of all shocks in our system. Third restriction, well, this Suez Canal event in March 2021. Fourth event, Shanghai, lockdown of the port of Shanghai in April 2022. Right? So this gives us a time series of global supply chain shocks. So here you see it. Again, a positive realization is a restrictive shock. A negative realization is an expansionary shock. Where we have highlighted the three events which we restrict. Importantly, we don't restrict necessarily the biggest events or the biggest shocks, but we want to restrict the model to be consistent with the narrative whenever we see the clearest cases of supply chain disruption. So you can easily see there are bigger events of shocks, but these are probably not the clearest cases of exogenous supply chain disruptions. Okay, well then we turn again to the microsite. We estimate relatively standard local projections. So you see on the left-hand side the change in prices of product I and product group J produced by firm F in month T. So lots of indices. And we explain that on the right-hand side by our epsilon. That's our global supply chain shock. Okay? And it's not just the epsilon, it's not just the global supply chain shock, but it's the shock multiplied by this export intensity, by this export share. That's like a treatment effect. That measures how strongly each firm depends on global supply chains. Right? And the coefficient we're interested in, well, that's the beta H. That tells us the effect of the shock today on the change in prices, or on prices, H periods after the shock. Right? So it's standard local projections. And this is if you don't distinguish between firms, then we get the picture on the left-hand side. So this is the response of producer prices over the month after the shock. And you see, well, producer prices increased by 1% after about 2 years. All right? So that's a very significant and strong response. Then, remember, this is on the micro level, on the product level. Then we rebuild the Swedish producer price index. Essentially, we put weights on each impulse response, and the weights correspond, well, to the weights in the producer price index. So that gives us the picture on the right. And interestingly, there the effect is twice as large as the average effect across the individual firms. Right? But again, also highly significant and relatively persistent for more than 2 years. And then, in the final step, we look at differences across firms. So we take the same model, but we differentiate between, between firm properties, essentially. For example, think of the size of firms. We split the sample of firms along the median of firms. So we differentiate large firms from small firms. Okay? And we do that by constructing this indicator variable I. So we are either in the first regression, which we index, or the first term there, which we index using the letter H, like high. And alternatively, we are in the second part, which we index L, like low. Okay? So each property of the firms is distinguished between two realizations, which gives us two beta coefficients, one for large firms, for example, one for small firms. All right? So here you see, for example, on the left-hand side, the responses of prices in green for small firms and in blue for large firms. Right? And what we do indeed see, well, the large firms respond much more strongly in terms of prices than the small firms. Okay? Well, what about inventories? Inventories is probably the one candidate variable that comes to mind when looking at the responses to supply chains? Well, we see indeed that firms with the low inventory holdings respond more strongly than firms with high inventory holdings. Importantly, this distinction between firms is dynamic, right? We don't require a firm to be in one group or the other over the full sample, but the firms can move between the two groups. What else I have? I have two more figures for you here. One is unit labor costs. Well, that essentially tells you how important is the wage bill for the total cost of the firm, which tells you that, costs of intermediate goods are less important if unit labor costs are high. So what we see is that firms in which unit labor costs play a small role, so everything else plays a larger role, they respond much more than firms which are essentially very labor intensive, which don't respond at all to the supply chain disruption. And finally, we distinguish market power, so we measure at the individual product level, we measure market shares of these Swedish firms, and we see, well, that those firms that have pricing power, that have a high market share, they indeed raise their price significantly, while those firms with relatively low market share and low market power do not raise their prices. So that's, I get the signal that my time is over. So let me conclude. That's what we do here is essentially two things. We identify this global supply chain disruption based on macro data, using sign restrictions and narrative restrictions, and then we use that to estimate the product level response of Swedish producer prices. Well, we do indeed find strong and significant responses, but also this heterogeneity across firms. Thank you very much.
Are there any questions from the audience directly? Yes, please.
Very, very nice paper. The only worry I have is about the use of the state in your analysis to distinguish between firm characteristics, small, large. You know, my intuition would be, just do a sample split, because state, as far as I understand this literature, means that you can change from one state to the other. And I think that, firms will probably not switch from one group to the other. So I don't think this is a state in that sense.
Well, maybe the terminology is bad that we use. Maybe we shouldn't avoid we should avoid the word state. But what we mean is that, well, in 1 year a firm can be small. The next year the firm could be large. We allow for that. They don't have to switch, but they can, right? If there is a takeover, one firm becomes a larger firm. We allow for that, but of course we don't force the firm to do that. So I think that gives us more flexibility. Whether you call it state or whatever, all we do is we distinguish
the problem with local projections is that having interactions is not straightforward. Yeah, and that is one of the reasons why this state approach has been developed. But that really requires that can be in a downward phase of the business cycle, an upward phase.
Yeah, but we don't. It's not like a regime switching model where the state evolves as a function of other things. It's like
how many firms do switch from large to small every year?
I don't have this number. I don't have this number. But again, it's not. We are not assuming that each individual firm shifts. The model is perfectly fine if we don't see any switch at all. It's just maybe the word state is wrong, right? But all we do is we distinguish between two types of firms. Whether there are switches or not, that's irrelevant for our result.
I mean, the Swedish microdata is very rich and has all kinds of firms in there, and you have maybe the very small firms with 10 employees, and then you have IKEA. Right, so, and one firm of 10 employees is not going to be the next IKEA. But that's a bit this distinction you make in your paper. But there's another question over here, please.
Yeah, very quick one. It's very nice paper, Peter. So it's really a driven supply side, and you look at the price response. So I was wondering about if you're looking also at export side, so how this affects the price of firms that exports, because I guess that's also affect the demand and profits. Did you look at profits?
Well, thanks, Guido. That's a very good point. Unfortunately, we don't have, we have annual data on firms' profits, like annual data on firms' balance sheets, which is not enough to really look at the impulse response functions, right? So at the high frequency, we only have the price data. And also the producer price data, not the export prices. But you're right, that would be nice to have, absolutely.
We have one more question here.
Thank you, Peter. Very nice presentation. Just two quick things. One, out of curiosity, on your narrative restrictions. I think the 3 events or 4 events you put there are very intuitive, but just out of curiosity, did you also, I mean, you could think about other events in terms of supply side restrictions. So I'm not sure if you did robustness checks on adding or taking out some of these events and whether results hold. And if so, I would be curious also to know what kind of events you also had considered. Yeah. And then the second point, more like on the identification, just as probably a nice robustness check to the way you identify the restrictions. There's some work also using PMI information on identifying supply bottleneck restrictions. So people at the ECB have worked on that. We did it at the time at Banque de France. So we used, for instance, in the PMI data, you have, for instance, components like supplier delivery time and these kind of things that you can also extract. So that could be, colleagues also did something very similar, I think, with this kind of data. So that could be a nice robustness check to what you're doing. If the Swedish case or the Swedish data is available for that as well.
I agree. Thanks very much. To the first point, we did not look at additional events, but what we do in the paper, we take out one of these events at a time to see whether the results are driven by one particular event. And what we see is essentially whatever we do, whatever combination of events we do, the results remain more or less unchanged. Well, probably what we need to do, we need to extend the data set, right? This ends 2 years ago or so. Now we have probably more events, like we have a war in Ukraine. We have other geopolitical events which we could use, which we don't use here in this paper. The second question is, of course, very well taken. Absolutely, I agree. We could use more data on Swedish PMIs. Here we don't. We have just this global supply chain pressure index. They include PMIs of all sorts of countries, but we haven't really looked at Swedish PMIs. But we could, yeah, I agree.
Thank you so much, Peter Tillman.
Thank you very much.
And now we move on to the next speaker, Rosie Chankova, who's going to be presenting the paper Energy Shocks, Consumption, Disparities and Inflation-Inequality Dilemma. Please.
All right. Yeah, thank you so much. The paper I'll be presenting today is called Energy Shocks, Consumption Disparities, and the Inflation-Inequality Dilemma. And it's co-authored with Momo Komatsu, who's another PhD student at Oxford. So let me start with some motivation. The first point to note is that energy prices are known to be very volatile. That not only applies when we think of energy prices as international commodities, but also as domestic consumer prices, which is what we care about. The second point is that the extent to which households are impacted by these energy shocks differs, and in particular for low-income households who allocate a larger share of their expenditure to energy, they are much more exposed and much more vulnerable to these energy shocks. The third point is that whenever energy prices increase, there tend to be some kind of short-term direct financial relief measures implemented, and we can think of different examples, things like tax rebates, subsidies and direct payments, or the suspension of certain taxes. So this brings us to our 2 research questions, which are first, we want to understand the distributional impacts of energy shocks, so understand how consumption inequality is affected and how consumption patterns for different households in the income distribution differ. And the second point is motivated by the recent stimulus checks in the US, which were at times criticized for being too broad, not being targeted at low-income households or vulnerable households. We want to think more about fiscal interventions that are targeted to lower income households in the context of an energy price shock and what that means for, or implies for the macroeconomy. Now, of course, our work is related to other studies that exist, in particular the literature, the large literature on the impact of energy shocks on the macroeconomy. There, different studies at times provide different magnitudes of the impact of these energy shocks, but there's consensus that when you're looking at supply-driven energy shocks, has a negative impact for output and consumption. What these studies don't consider, though, are the heterogeneous implications. Or any thoughts about heterogeneity across the income distribution? And that's where we come in, and why our work is related to the heterogeneous agent literature. So how we contribute is by finding that not only does consumption fall, but actually consumption inequality increases, and by providing this framework for targeted versus untargeted fiscal transfers, which I'll define in a second, we see that with targeted fiscal transfers towards low-income households, there's a trade-off between inflation and inequality. So let me give you some data. And in particular, we can look at the energy expenditure shares across the income distribution in the United States. Here we see clearly that lower-income households allocate a larger share of their expenditure to energy than high-income households. In particular, for the lower end on the income distribution, we're seeing around 13% of expenditure goes towards energy, while on the higher end of the income distribution, that's only about 5%. Now, we're looking at the US because we were able to get this more granular data available at quarterly frequency, which is the consumer expenditure data. It's very granular, so it allows us to construct these time-varying shares that are income-specific, not only for energy, but also for some other items in the consumption basket. So then with these time-varying and income-specific shares or weights, we then construct income-specific inflation rates. And so here, the gray lines indicate the inflation rates for different deciles, and I've highlighted in blue the inflation rates for the bottom 20% of households, and in red for the top 20% of households on the income distribution. What we can see are two things. First of all, we do note that the inflation rates for the different households tend to move together most of the time. But we also see that since the inflation rates for the lower income households is more volatile, you get these gaps at certain times. And these gaps in the inflation between low income households and high income households is what we care about and what we want to understand a little bit more. So to do that, we look at the correlation between the inflation gap of low income and high income households, and plot that, look at the correlation between that and different measures of inflation. Here looking at energy inflation, food inflation, and core goods and services inflation. And what we see very clearly is that the inflation gap is most strongly correlated with energy inflation. So this explains why we care so much about energy shocks when thinking about inflation heterogeneity. Now let's make things a little bit more formal. And here, for our empirical methodology, we developed this instrumental variable local projections framework, where in the first stage, we instrument energy prices with supply-driven shocks from OPEC announcements. So those are news shocks developed by Kensick. And then in the second stage, which is the dynamic response, where we look at the dynamic response of consumption. Here, consumption is in terms of log deviations from trend, in real terms, of course. What we care about mostly is in red the beta coefficient, so how consumption is impacted from those fitted values of energy prices. I've also highlighted in blue the variables which are income group specific. So the second stage regression, or the second stage, we run across different income groups, which is what gives us the income group specific betas and allows us to compare that. So let's look at some results. First, we see that when we include all the households in our sample, we note that following a supply-driven energy shock, consumption falls by 0.25 percentage points, and that negative impact lasts for around 5 quarters. This is pretty much consistent with other studies that have looked at the aggregate impact of energy shocks. However, things get a little bit more interesting is when we look at how the implications differ depending on whether households have low or high income income. So here we see that following an energy shock, the consumption of the highest 10% income earners in red is not really responsive at all. Instead, for the lowest 10% of income earners, there's on impact 0.5 percentage point reduction in their overall consumption, and that negative impact lasts for around 3 quarters. Now we can not only look at the top and bottom 10% across the income distribution, we can look at everybody, all the households in between. The graph gets very messy when you include all of the deciles. So what I've done here is plotted only the contemporaneous impact. So looking at the 0 horizon. And we see very clearly still that across the different deciles, the contemporaneous effect is larger for the lower income households more negative, while for the higher income households, the magnitude of the decline in consumption is much smaller. The last thing we do on the empirical side is we not only are interested in how much consumption falls or is affected, we also want to understand better the consumption patterns, which parts of consumption are affected, is there any redistribution going on? And what we can see, so we've disaggregated total consumption across core goods and services, energy goods, and food at home. When it comes to core goods and services, that is very similar to what we already saw with total consumption. Core is also the largest share in the consumption basket, so that makes sense. When we look at the energy goods, we actually do see a larger response, especially for the lower income households, where consumption falls by, on impact, 0.75 percentage points, and also lasts much longer. Interestingly, though, when it comes to food consumption, for now the lower income households, there is no response at all to these energy shocks, while instead for the higher income households, we do see a small reduction by 0.25 percentage points. So let me sum this up. What we see is that even though aggregate consumption falls, or like overall consumption for all households falls, consumption inequality increases. And when we look at the composition, we do see that these effects are not uniform. Now let me turn to the model that we have, which we use to rationalize our results and do some counterfactual policy analysis. And I'll do this very brief in the interest of time. So we've got this new Keynesian model with 2 households, a share lambda of constrained households, and a 1 minus lambda share of unconstrained households. We're going to think of the constrained households as being low income and unconstrained as high income, and we're going to talk more about that in a second. We've got these 2 sectors, rest and energy, where using Rothenberg pricing, the rest sector has a higher adjustment cost, so is stickier. And we also use non-parametric preferences to match that low-income households allocate a larger share of their expenditure to energy. Let me talk more about the household heterogeneity. And here we use the indirect utility function from Boppard, which allows us to account for the income effect. And here this variable SKT, which gives the total spending for constrained and unconstrained households, is key. And we see that more when we look at the budget constraint for the constrained and unconstrained households, where both receive the same wage. They receive some kind of transfers, where in our baseline scenario, which as untargeted fiscal policy, tau C and tau U are going to be equal. The unconstrained households also receive or have access to the bond market. However, what's important here is that the unconstrained households also have this red bit, which are the full untaxed firm profits. This makes them permanently wealthier, so allows us to think of them as the higher income households, and gives them a lower marginal propensity to consume than for the constrained households. Monetary policy is standard, just a standard Taylor rule, and the fiscal policy also follows the Bilby framework. The tau parameter is what we're going to play around with when we talk about targeted versus untargeted fiscal policy. So targeted means that, so untargeted, which the baseline means that we set tau such that tau C and tau U are equal, while in the targeted scenario, we play around with tau such that only constrained households receive the transfers. Now let's briefly look at the results here. We see that overall consumption for constrained households falls a lot more than that of the unconstrained households, mirroring what we saw in the empirical results. We also can note that when it comes to the consumption of constrained households, they see a larger reduction in their consumption of rest goods, again, consistent with what we saw from the empirical results. For the unconstrained households, their consumption of energy and rest goods falls by pretty much the same magnitude, but then the convergence back to the pre-shock level for energy is slower. We can also note that inflation for energy increases, while that for the rest good falls. Consumption inequality increases, and given the Taylor rule, the central bank raises interest rates. So this is happening in our baseline scenario where both households receive the same transfers. Let's think a little bit more about the counterfactual analysis that we do, where we look at untargeted versus targeted fiscal policy. So here it's looking at consumption inequality, inflation, and nominal interest rates. In the untargeted fiscal policy scenario, all of those things increase. However, when we only give transfers to the low-income households, or the constrained households, we actually see that consumption inequality falls. However, given the higher marginal propensity to consume of those constrained households, inflation rises a lot more, so that the central bank needs to intervene much stronger. This is what we refer to as the trade-off between inequality and inflation in the context of an energy price shock, and is kind of exactly what emphasizes the interaction between fiscal and monetary policy in this context, and what we think deserves a lot more attention. So let me sum up. What we've shown is that following energy price shocks coming from the supply side, overall consumption falls. However, consumption inequality increases as the consumption of low-income households falls significantly, while that of high-income households is unaffected. And we also see that there are differences across different consumption items. And finally, using our model, we show that this targeted scenario, a targeted fiscal transfer scenario, while helping to reduce consumption inequality, comes at a cost of higher inflation and higher interest rates, giving us this trade-off. Now, this is still some work in progress, so we need to work on improving the calibration, matching empirical moments to the theoretical ones, and we also want to strengthen the fiscal policy analysis. So if you've got any comments on that, that would be much appreciated. Thank you very much.
Again, are there any questions from the audience? Please.
Yes, David Marsh here. Yes, I've got a question just to make your life more complicated, really. I've seen some research by somebody, and I'm sure you know, Günther Schnabel from Leipzig University. He tries to paint together all these different data on consumption, inequality, and so on with voting intentions. And clearly that would be another dimension of cause and effect. And I'm not suggesting that you do this part of your Oxford studies, but I just threw it out as a general political economy idea. If one could develop a methodology for all this, and I think it has been done, wouldn't that be very, very useful for policymakers, because they need to second guess not all just the counterfactual fiscal effect and so on, but also the potential political effect when we see this far-right surge everywhere. We heard a bit about that, I think, from Oscar yesterday, talking about another impact, which is the growth of the foreign workforce. That clearly does have an impact as well. So I just throw this out as a general idea for discussion rather than expecting any instant answers.
Yeah. No, I mean, thank you so much. I mean, of course, inequality is a very political or politicized issues, energy prices as well. So definitely that could be interesting. Yeah.
Guido?
Hi, very nice paper. Just one question. I don't think you can do it in the data, but I was wondering if you can check also the quality of consumption. You probably look at expenditures, right?
Yeah.
But there is some evidence that, you know, especially for food, for example, they just buy more low-quality food. They change, you know, supermarket chains and stuff like this. And the other thing is, I think for taxes, you can try to maybe model the response of some countries. You know, subsidies maybe directly linked to the price of energy or the consumption of energy, rather than, you know, general taxation as you do it now.
Absolutely. I mean, the quality issue of what kind of items consumers buy, we would expect those to differ across the income distribution. You would need some scanner data for that, which is difficult to get, and wouldn't allow us to look at at energy expenditure. So that's a bit of the trick, but definitely that's why the inflation measures which we have for income groups are only sort of approximations, because we keep the sort of energy inflation, food inflation, these things are constant or like the same across the different income groups. Yeah.
We have another question there in the back from Marie.
Yeah, this is really a cool paper. Did you look at optimal monetary policy? Because here you have a Taylor rule. We know from Bill B. and the Bertolli-Galli that essentially there would be a trade-off between inequality and inflation targeting in this framework, but it's a very weak trade-off, and actually the central bank typically would still have a very strong incentive to tamp down inflation. Is that still true in your framework?
So we have not looked at optimal monetary policy. We were thinking of that, and we could actually still do it. We then eventually shifted into this more fiscal aspect, because we thought that, or from news, from kind of reading the current situation, it seemed that these transfers are what we saw is that when energy inflation increased, you had the fiscal response targeted at that. Central banks did, more indirectly raised rates sort of as the consequence of everything. But I mean, it's certainly something that one could explore further. Yeah.
We have time for one more question, please.
Thank you for the presentation. I have two questions, actually one question. Have you also analyzed the delay between the global energy shocks, and between the disruption in the consumption pattern, and the delay between the energy shock, the disruption in the consumption pattern, and the state intervention with any kind of policy like transfers to the low-income households? Thank you.
Thanks. I mean, so on the first part, from our local projections, the impact to consumption is instant. Essentially, you have an on-impact effect from these oil price shocks, which are essentially global supply-side shocks. And on your second question, sorry, could you repeat that? So the state, right? Sorry. So for that, no, it's not something that. So we don't look at the state interventions in the empirical component. That only is part of our theoretical model. So in the empirical part, we only focus on these supply-driven energy shocks. Yeah.
Thank you very much, Rosie. And now you need to beware of large shocks. And welcome Elena Bobecker on the stage from the ECB.
Thank you. Good morning. So thanks a lot to the organizers for having our paper in this great event. So I think the paper follows nicely the first two papers of the day, looking at the global supply chain pressures and at energy shocks. So we're going to present you this relatively new paper. It came out as an ECB working paper a few weeks ago, entitled Beware of Large Shocks, a Non-Parametric Structural Inflation Model. And this is joint work with my colleagues at the ECB, Sarah Holton, who's also here, and Catalina Martinez-Hernandez, and Florian Huber from the University of Salzburg. The usual disclaimer applies. So the motivation of our paper is rooted in the post-pandemic inflation surge, when really the unusually large underpredictions of inflation led us to believe that there are some important mechanisms missing from our traditional models. And then there was an interest of employing larger models, looking at more and new types of shocks, such as global supply chain pressure shocks or more types of energy shocks. But even when we do that, still part of the inflation surge remains unexplained. So what we argue is that what economists missed in that period is also a nonlinear transmission of these large shocks. And when we dug in the literature looking for a model that allows us to answer these questions, we identified a gap. So basically a model that is flexible on the type of nonlinearity out there and also allows for structural inference. And it does it in one go, so we don't have to resort to local projections, for instance. So that's what we do here in this paper. So we built a non-parametric structural inflation model that is flexible in the way we capture nonlinearities between economic variables, and that also allows us to identify shocks. We focus on energy shocks because they have been a major source of inflation volatility and of inflation forecasting errors. And we've also seen unprecedented shocks now when it comes to the last few years affecting euro area inflation. We find that indeed larger shocks have a disproportionately larger impact on inflation, and that this nonlinearity is visible more strongly at the beginning of the pricing chain, but present also more downstream. And this nonlinearity is visible also for other shocks, but stronger for energy. The model that we build also stands the test of forecasting. I will present you later. So let us start with the first visualization of the data as an empirical motivation as well. So here you have the relationship between headline inflation in the euro area and the synthetic energy commodity price indicator. Why do we look at the synthetic energy commodity price indicator? It basically merges gas and oil commodity prices according to the euro area import share, because one of the lessons of the last few years was that gas also matters a lot. So you see that the relationship has shifted, and of course if you want to read something in a scatter plot, you could also say that the relationship becomes stronger when you have large positive shocks on the energy market, and perhaps to a smaller extent also when you have large negative shocks. But of course we're going to investigate this more formally. So theory backs up our intuition that large shocks would elicit a disproportionate effect of inflation. So I'm going to bring in three lines of arguments. First, menu costs. Now, so we know from the seminal paper of Ball and Mankiw in '95 that firms have a range of inaction in response to shocks. So this is because of the adjustment costs, so the menu costs, and they would react only to shocks if they surpass a certain threshold. We also know that prices become more flexible when we are hit by large shocks and we are in a high inflation regime. And we have a lot of evidence from micro-based studies that tell us that the size and the frequency of price adjustment are actually endogenous to the various economic states, to the inflation regime, to the size of the shocks. And we know that for the euro area, for instance, we did see an increase in the frequency of price adjustment in the inflation surge episode, so prices have become more flexible. And finally, we also know that consumers find it harder to discriminate among products when there is a high inflation, when they are hit by large shocks, which makes it easier for firms to pass on cost shocks. So the theory is quite, let's say, affirmative in stating that such large shocks would lead to a stronger pass-through. But when we looked at the empirical literature, we found it rather limited when it came to the impact on inflation. So on the impact of large shocks having stronger impacts on inflation, We have the paper by Guido Ascari here, who's also in the room, and Haber. For now, you're looking at the impact of monetary policy shocks, and you find this nonlinearity by employing these smooth local projections. But in general, papers are looking more at differentiated reactions when we are in a high inflation versus a low inflation regime, or they also find stronger reactions after the pandemic. So we think we can contribute to this literature and also fill a gap when it comes to the impact of various shocks on inflation. Now, how do we do that, and how do we remain agnostic on the type of nonlinearity and why this is important? Well, economists tend to agree that inflation behaves in a nonlinear way. I mean, starting with the seminal idea of Phillips that wage inflation reacts nonlinearly to unemployment. But where economists don't really agree is how to model this nonlinearity. And most often, the modelers would impose ex ante a type of nonlinearity in a rigid way. So either they would assume a world of two regimes, or they would even think of L-shaped relationships when it comes, for instance, to the Phillips curve, an L-shaped type of Phillips curve, or they would look at dummies or quantile regressions or things like that. But now these advancements in machine learning techniques allow us to be very flexible on what type of nonlinearity governs the data. So these types of techniques have been used with success in forecasting. So I'm quoting here works by Philippe Coulomb, by our colleagues at DCB, Lenz et al., and also I would like to mention, as we are in Vienna here, from the Austrian school now with Florian Huber and Hausenberger. So I think these models are very promising also for structural inference, as we are going to show you today. Our model, let us start with the simple representation of our data. So our time series vector yt can be decomposed basically into our regressors xt, which are the lags of our data, and a set of fundamental shocks qt. So xt affects our time series through the function f, and the fundamental shocks affect our time series through the function g. So you already see now here something different, that we have this g of qt, which is separate from our measurement errors, and these are our fundamental shocks, and the function g will allow us to look at nonlinear responses. So let us decompose these functions a bit further. So we assume that each of these functions that I talked about, f and g, can be further decomposed into a linear part that is more known to us and a non-linear bit. So if we look at the impact of our regressors on yt, they would affect yt through the function f that could be decomposed in a linear part, and this a of xt is basically a VAR. Part that we are very familiar with. But we assume that there could also be a non-linear addition, this f tilde function. When we look now at structural shocks, they would be impacting our time series through a linear part, this lambda qt, and then we also allow for possible nonlinearities via the function g tilde. So as I mentioned, the AXT part is relatively known. This lambda qt part comes from, is a linear part, but it's basically driven by this work of Korobilis in 2022 that tells us that our reduced form residuals are actually driven by only a set of fundamental shocks. So with this dimensionality reduction technique, we actually can say that even if we have 10 time series in our model, we actually have only 4 structural shocks governing them. So this is a factor model representation. And I think also that the nice part about it is that it allows us to basically circumvent this accept-reject algorithm of imposing sign restrictions, as we've seen this morning. And indirectly in the estimation phase, we impose sign and zero restrictions on the elements of the lambda matrix, the loading matrix there. So this is where we impose our restrictions on this lambda, and this is, as I said, also similar to the Korobilis paper in 2022. But what is new is how we estimate this g tilde and f tilde, the nonlinear bits. So here is where we borrow from this machine learning literature, and we apply Bayesian additive regression trees that are a very simple and also elegant way of approximating through our function, our known functions, by averaging across many trees of a smaller scale. So why do we choose that? It helps us to avoid overfitting. And we approximate here in this non-parametric way across around 50 trees. So this is a representation of such a tree, which is basically a series of decision rules, binary decision rules, and this is a tree that is estimated for German GDP. You would see how it depends on the various variables, covariates that we have in the model at each step. So the data that we have basically focuses on headline inflation, as I mentioned. I will discuss about the endogenous variables in a second, and just to mention that our sample covers the data starting 96 to 2024. One word about identification, because in such a flexible model, you need to impose a bit more than usual. So first of all, we have this assumption that, the linear part would dominate. So we have tight priors on the linear VAR part to account for most of the persistence of our data. So really, our prior is that the nonlinear bits would really soak up the remainder term. Also, because we have nonlinear parts in both when it comes to the impact of our regressors and our structural shocks, in order to avoid overfitting, we fixed the explained share of variance in the data to 95%, so something like a 95% R squared, and we leave 5% to the residual. But we also found that the results are not so sensitive to this choice. For the economic identification, we also apply sign and zero restrictions, also as we've seen in the morning, and we also have a scaling a restriction, a kind of a magnitude restriction, in order to scale our structural shocks, which come out of this factor representation. So, for instance, we restrict the elements of our matrix lambda so that a one unit energy shock creates a 1 standard deviation increase in the synthetic indicator. So this is just for scaling. This is our structural identification. We focus on 4 structural shocks. So energy, global supply chains, domestic supply, and demand. So among our variables, we also have some more timely, let's say, survey variables from the European Commission, this price expectations in manufacturing and the consumer confidence that allow us to pin down supply and demand. So obviously, we would assume that our demand shocks would move nominal variables and the consumer confidence in the same direction, and supply shocks in opposite directions. So let me probably dwell a bit on the global supply chain shock, because this was discussed this morning and is relatively newer in the literature. We pin it down using the GSCPI indicator of the New York Fed, but also the PMI supplier delivery times tailored more to the euro area conditions. So, as we heard the comment this morning by Stefan. And we try to be very flexible and parsimonious in the restrictions that we introduce in the model. Now, so we really go for a minimal set of restrictions. And we assume that obviously this is a supply shock, so it would increase the nominal variables, it would decrease the consumer confidence. And the challenge is to distinguish it between, from the energy shock. So here we would assume, no, we can impose the zero restriction that energy commodity prices don't react to these shocks, really to make it more of a production network kind of shocks and not an energy one. So, let me go through the key result of our paper, and it's actually what we're proposing here is a way of getting nonlinear impulse responses in a VAR. And here you have the response of headline inflation to shocks in energy prices of different sizes, small, medium, and large, 1, 2, 3 standard deviation. And these shocks, these IRFs are scaled for comparability to the 1 standard deviation shock. So in a linear VAR, you would see that the lines overlap. But what we see here is that there is some evidence of nonlinearity saying that indeed larger shocks elicit stronger reactions in inflation. So in line with the theory spelled out by Paul and Mank, you would have that small shocks don't trigger significant reactions. Now is this range of inaction for firms. But then when we move to medium-sized shocks, the red line, you would already see a peak impact that is around 2.5 times larger than those than the impact elicited by the small shocks. So also interestingly is that this non-linearity is more visible, more upstream. So as we move down the pricing chain, the non-linearity gets attenuated. So here you have the same picture, but for the synthetic energy commodity price indicator for the PPI energy and consumer prices. And you see that obviously also the reaction to shocks is immediate on the commodity prices and then relatively fast and strong for producer prices for energy. And then it gets attenuated if you look at the scale of the chart, and then also a bit more delayed when it comes to consumer prices. And so goes for the nonlinearity. As energy inputs become, let's say, their share becomes smaller in total costs, firms are also able to buffer buffer this input a bit better and buffer the cost from energy. So maybe before getting to this picture, maybe it's also worth saying that what we also checked, and we can do that with this machinery, is whether really we can think about these reactions in regimes. Is it the small versus large shocks, as we would normally do? But actually, no, because we can we have this chart in our paper. We can produce these generalized impulse responses to a grid of shock sizes, and we can see that actually this nonlinearity and this disproportionate response increases with the size of the shock. So it's a relatively smooth function of that. So indeed, the regime type of thinking is a bit of a simplification. Now we also checked the nonlinearity also for other shocks. And here, this picture would show you the responses of inflation for shocks of different sizes, 1, 2, 3 standard deviations, and for different horizons, so 0, 6, and 12 months ahead. Indeed, these are all scaled for comparability. Indeed, the reaction of inflation is stronger as the size of the shock increases. But perhaps you see it more for energy shocks. No? So for instance, for the demand and supply, we also have a bit more uncertainty in estimating and pinning down these generic shocks, actually. And why do you think that we see it stronger in energy shocks? Well, it's also now economically a very upstream shock, and that would affect firms in a more similar way compared to other shocks. But also the data helps us because we have in our sample more instances of large energy shocks, and the last years definitely help. So we validate our model from a forecasting perspective. We choose a tough-to-beat benchmark. Okay, thanks a lot. We have 1 minute. So it's the linear version of our VAR, and it also has stochastic volatility, so we know it's hard to beat when it comes to forecasting. We evaluate density forecasts, the CRPS scores, also when it's right-tailed, so we're looking more at the right tail of the HICP outcome, and when it's left-tailed. So what we see here in relative terms compared to a linear VAR in our forecast evaluation, in the table, if you see numbers that are lower than 1, that means that our model beats the linear version, is that the model also fares well in forecasting. So it does manage to capture the dynamics in the data, also when we look at this metric, the out-of-sample forecasting. And out of curiosity, as a byproduct of our data, we looked at how do the errors produced by our models in an unconditional way compared to the errors of the official projections of the ECB. And these are like the 1 quarter ahead forecast errors. We know again that this is a tough-to-beat benchmark because there is also judgment involved. Sometimes we have 1 month of data for large countries. And our model is very competitive, and it even improves in the period of the inflation surge. So to conclude, basically we propose a new model with nonlinear features that allows us to be flexible on the type of nonlinearity out there and allows us to identify shocks in one go. It has good forecasting properties compared to competitive VAR. And we do find the large shocks generate disproportional inflation responses. And of course, this paper also would fit into this discussion of seeing through shocks or supply shocks or not. But now our results point to the fact that large shocks transmit differently, and therefore they may require differentiated responses. Thank you.
Again, are there any questions directly from the audience? Yes, please.
You are focusing on structural shocks and the relationship to inflation, and especially singling out big structural or energy shocks. Yeah. Now, just from sort of looking at the behavior of data during your observation period, yeah, it seems that you only observe one large energy price shock. Yeah? And now it could be that this is posing an identification problem for you, because one could also put forward the hypothesis that this one large energy price shock is coming together with, let's say, an inherited excess money supply shock. Yeah, and is this something within your model structure you could deal with, or you could make you could comment on?
Thank you very much. It's an interesting comment. So can we go have the slides again up? Thanks a lot. Yeah, so we don't have money explicitly in the model, but we do account for demand shocks as well. At least that would cover generically. So our generic demand shocks would cover monetary policy as well. And in terms of one large energy shocks, if it does pose identification issues, our samples goes quite far back in '96. And we've seen, I think I have in the background a chart on how these identified energy shocks look like. Well, we've seen large shocks also in other periods, so around 2008, 2009, and obviously the last period is really outstanding with a different really regime when it comes to volatility and size of the shocks, but it's not really only one shock. Now using the monthly data, there are more. And to the second part of your question, that's what we have to say about it in the paper, just by controlling for a demand shock, but we have not really included money. Thanks a lot.
And here we have another question.
Yeah, very nice paper. So I have a question regarding, so you have a nonlinear part only on this, also on the structural, on the variable, on the observable. So actually also in your framework, the same shock will have a different effect depending on each quarter, right? Because it depends also on X, and you have a nonlinear part of this. So I just wonder if you have looked at that, if you look at how different shocks affects the model in your sample, and that actually might be related to the question about money supply. If you put money supply in the model, then the response to whatever shock would be depending also on the level of money supply, I guess, right? Because through the nonlinear part of the model. Second question regarding the forecast comparison. So if you compare to a standard, let's say, BVAR, it seems to me, I mean, of course, you compare to the euro area forecast, that in tranquil time, actually the model does worse, but it does better in, when something happens. Is that correct? And if that's correct, should we use this, both of them together, and in order to use this tool as a robustness with respect to standard linear models?
Thanks a lot for the great questions. Again, if you could put up the slides, sorry to the organizers. So indeed, we have different sources of nonlinearities. The relationship between variables could change. but also the impact of the shock would be non-linear also contemporaneously. So we've checked different versions of the model, and we saw that indeed what is more likely to trigger this non-linear impact is this G tilde, so directly the impact of shocks on our YT vector, and while F tilde is relatively less important. So that was an interesting insight also for us. And on the second paper, on the second question, which I think is a very valid point and has a lot of implication for our modeling toolkit in general. So I would not say that the model fares worse compared to a linear version in tranquil times. It is relatively similar. So let's say that our takeaway is that in normal times we are safe in using traditional linear models, but when we have these abnormal situations and large shocks hit is when a non-linearity actually helps. Thank you.
Are there any more questions from the audience? There is one more, yes.
Thank you for the presentation. One question about currency rates. Did you also influence euro against the US dollar, because commodity prices are mainly in US dollars? So did you also include in your analysis the currency trade?
Yes, no, it's a very valid point. We have exchange rate in our data set, but also our energy commodity price indicator is expressed in euro. So this is really talking about an impact directly on euro area consumer prices. Thank you.
Okay, thank you, Elena.
Thank you very much.
And now we have one more presentation by Thomas Kroen, but he's not here physically today. He will join us online. So let's see and hope we have already a connection. Hi, Thomas. Can you hear and see us?
Hey, good morning.
Good morning.
You can hear me as well, I assume?
All very good, yes. Then, please, you have the stage.
Okay, thank you so much. Okay, so thanks a lot to the organizers for having our paper on the program and for allowing for virtual presentation. This is joint work with Jorge Alvarez, also from the International Monetary Fund, and so the usual disclaimer applies. After seeing already a range of papers on energy and other types of shocks that were particular to the recent period, what we're after in this paper is the energy origins of the global inflation surge that we saw in recent years. In particular, the main motivating observations are, on the one hand, the large increase in inflation, notably in 21 and 2022, and then decline, which coincided with a period of large and extraordinarily large energy shocks. And so the question we want to ask in this paper is, what was the magnitude of the pass-through of energy prices during this recent period? How does it compare historically to previous episodes? And what's the role, if we go beyond the aggregate level, what's the role of structural sectoral characteristics in shaping energy price through at the sectoral level and then at the aggregate level? And ex ante, the comparison of energy price pass-through between the recent COVID period and prior periods may be unclear. On one hand, models with price adjustment frictions may tell us that conditional on the size of the shock, the pass-through of energy prices into inflation may be similar. There's small shocks and firms may not adjust. There's larger shocks and then there may be adjustments, but once we condition on the size of these shocks, that may be comparable. On the other hand, if there were stronger, for example, general equilibrium feedbacks, wage price spirals, and other mechanisms at play, then the pass-through could be stronger than what was previously observed. What we do in this paper is build a new multi-country, multi-sector data set. It will cover over 30 countries and 11 sectors per country. And then we'll exploit both the aggregate country level and the granular sector level dimension using a local projections approach to study then the pass-through of energy prices. with overall 3 main findings. The pass-through to headline inflation was comparable to past episodes. Second, non-linearities are present, notably in advanced economies. We don't see clear evidence that those strengthened systematically. And going then to the sectoral level, we see that sectoral energy dependence and sectoral price flexibility shape how energy prices pass through into sectoral measures of inflation. And perhaps not surprisingly, more energy dependent, but also more price flexible sectors tend to have stronger energy price pass through. Of course, there's a large literature that has looked at some of these questions, including some of the papers that we've seen as well earlier in this session. And we see the contribution of this paper is providing a multi-country, multi-sector dimension relative to some of the empirical work that has been done in that space, not making a structural modeling contribution. We hope that perhaps some of the empirical moments can inform future structural modeling work. So before jumping into the details, let me give you a few stylized facts before then going over the data and the main results. Looking across countries and also across time, one feature that stands out of the recent period at the aggregate level is that energy price changes. So here we're plotting the distribution of quarterly energy price changes across countries and for roughly the last 3.5 decades. The distribution, the thick red line in the last couple of years, had significantly thicker tails and was significantly more dispersed than what we observed in the prior decades, both on the upside, but also on the downside. Zooming into this, at the sectoral level, we split sectors by whether they have high or low energy dependence. And as you can see, during the recent inflation surge, inflation was initially driven by sectors that have above median energy dependence. That's where inflation surged early on, but then also came down quite strongly. While inflation in those sectors with lower energy dependence, a dashed line here, took quite a bit longer until it was affected, but may have turned out to actually be more persistent down the road. So with these stylized facts in mind, let me give an overview of the data and empirical strategy. At the aggregate level, we collect primarily data from the IMF World Economic Outlook database and complement that with a country-level measure of energy inflation. Then go one step further and study sectoral inflation dynamics. This presentation will primarily rely on data from the OECD that allows us to construct sectoral value-added deflators at the country level for 11 sectors per country that are exhaustive across the economy. We do additional work in the paper where we use sectoral PPI data from Eurostat. It comes with the one caveat that it's not fully exhaustive. There are some missing sectors. That's why here we'll focus on the OECD data. Further, then to get at energy dependence, we use the OECD inter-country input-output tables. They give us the input-output linkages, both within countries and across countries, which is important, especially in the context of energy, where many countries rely on imported energy inputs. So relying purely on national input-output tables may miss some of those links of traded energy that's being used as an input in other countries. And then we complement that with data on sectoral price flexibility and sectoral repricing frequencies from Elisa Rubel. That's going to give us some information on how quickly different sectors reset prices on average. This gives us then a final sample of 33 countries with country and sectoral data, about 25 advanced economies and 8 emerging markets, with 11 sectors per country. And we'll focus on the recent period with a quarterly sample covering 2010 to 2024. Just to illustrate how we construct energy dependence requires 2 steps. First, defining the energy sector, and then having a measure of energy dependence. So we define the energy sector using these fairly granular input-output tables. We have a total of 45 sectors. We define it as coke and refined petroleum products and utilities, where utilities captures gas, electricity, and steam in particular. Then we have two primary measures of energy dependence. One, very simply, we take the share of a particular input relative to gross output that's being used in a sector, and this matrix omega tilde that collects all of these shares in one place. Then the direct energy share is simply how much does a particular sector use coke and refined petroleum products and utilities as a share of its sectoral gross output. Now, of course, we know that there may be indirect usage of energy. Maybe a sector purchases goods from another sector, and that other sector may be very energy dependent. So the first sector may have some indirect energy dependence or reliance on energy through some of the intermediates that it uses. So then, using the Leontief inverse, we construct the total energy dependence that both captures the direct energy links, but also the indirect links across a production network. Looking at how these two measures compare across countries, show here on the bottom how total energy and direct energy dependence, so the two gammas constructed here, correlate across countries and time. And as we can see, there's a fairly strong positive correlation. We confirm that using alternative definitions of the energy sector. Also confirmed that after residualizing on country fixed effects and time fixed effects to take out some of that variation may be present. And so what that tells us is, given that these measures are fairly correlated, for our purposes here, we'll focus on the total energy dependence of a sector when going to the sectoral results. It's going to tell us how much a sector relies both directly and indirectly on energy as an input. Then equipped with this data, we'll run two sets of exercises. First, a set of country-level regressions. And we'll be interested in how changes in energy prices pass through into headline inflation. We'll first be interested in this sequence of coefficients beta h in red, which tell us something about the baseline pass-through. And then we interact energy price changes with a dummy for the post-2020 period. And so we'll be interested in the sequence of coefficients gamma h that tells us something about whether pass-through may have changed. We'll show you later on also nonlinear specification that augments this specification. Put a range of control variables, and we may vary potentially this measure of energy inflation. It may not be fully exogenous, so we run as well in the paper a robustness check where we use the Diego Kensick 2021 oil supply news shock as an instrumental variable for country-level energy prices. We find that has a fairly robust first stage predictive power, and as well gives us robust results for the second stage. We then also go one step further at the sectoral level and ask at the bottom of the slide, how does the pass-through, now looking at sectoral measures, so pi in country I, sector J, at a given time horizon, how do these measures, or how does the pass-through depend on the interaction of energy prices and sectoral characteristics? These characteristics Z, we'll look at sectoral energy dependence and price flexibility at the sectoral level. And so with that, let me give you a preview of the three main results in the paper. First, looking at the baseline energy price pass-through, both across advanced economies and emerging markets, and we split the sample for reasons I'll explain in a minute. The baseline energy pass-through in advanced economies on the left-hand side, that's a red sequence of coefficients. It's about 0.06 to 0.07 percentage point increase in headline inflation for a 1 percentage point increase in energy price inflation. For emerging markets, developing economies, the pass-through is about twice as large in our sample. However, importantly, looking at the blue lines, so the sequence of gamma coefficients, the post-COVID pass-through, conditional on the size of the shock, is not significantly different or did not change significantly relative to this baseline pass-through. Also check relative to the literature and different papers that have been done, partly on different samples, our baseline pass-through is broadly comparable in magnitudes to what has been found before. Now you may worry, and we already saw a paper on nonlinearities, if there are price adjustment frictions, the response may depend on the size of the energy price change. And so we augment the previous specification with these nonlinear terms. So we don't just have this beta 1, we add a beta 2 and beta 3, and as well for the gammas. What we find is for small energy price increase, we use a 1 percentage point energy price change. Pass-through is smaller, about 4 to 5% pass-through at the peak, while for a large energy price increase, the pass-through peaks at about 10%, so almost twice as large. This is here for advanced economies. For emerging markets, the evidence is less clear. So these nonlinearities are present in advanced economies in their inflation pass-through. However, looking at the blue lines, so the changes in this nonlinear pass-through, don't see clear evidence for a change in the nonlinearities of the energy price pass-through. So with these aggregate results, we next ask if the pass-through was relatively comparable, counting for nonlinearities to previous episodes, what do we know at the sectoral level, or what are some sectoral characteristics that may explain the extent of energy price pass-through? Going to our sectoral measures, so we'll have 33 countries I, but now also 11 sectors per country. We interact the energy price change with sectoral energy dependence and then price flexibility. We find that pass-through is stronger in more energy-dependent sectors. To give a sense of the magnitude, for a 10 percentage point energy price change, a sector with a 1 standard deviation larger energy dependence has about 0.5 percentage points higher inflation relative to a sector with 1 standard deviation less energy dependence. Now, 10 percentage point energy price increase for the COVID period is fairly modest relative to some of the shocks that we've seen. And so these magnitudes in the sector, in the cross-section of sectors, are sizable potentially. Similarly, we look at, on the right-hand side, at the importance of sectoral price flexibility. Sectors with more flexible prices do have stronger pass-through from energy price changes. To give again a sense of the magnitude, for a 10 percentage point increase in energy prices, there's about 0.2% stronger and higher inflation in a 1 standard deviation more price flexible sectors. Also look in the paper, just going one step further, you may wonder, energy dependence and price flexibility may correlate across sectors. So we show that conditioning on one of these two characteristics, there is explanatory power of the other one. So while there's actually some correlation in the data between these two characteristics, they do not perfectly overlap. With this, let me conclude. So what we do in this paper is analyze the inflation pass-through from energy prices to headline inflation during the recent period and compare it to previous episodes. We broadly find that pass-through to headline inflation was comparable to past episodes. Nonlinearities are present, notably in advanced economies, but we don't see clear evidence that these strengthened systematically. And third, at the sectoral level, sectoral characteristics, in particular energy dependence and price flexibility, shape the sectoral inflation pass-through. And so from that perspective, looking forward, understanding sectoral characteristics and interlinkages is important. Having potentially better data on price setting and intersectoral connectivity, perhaps other sector-specific structural characteristics, could be valuable to understand the sectoral linkages and how they shape the pass-through from energy prices into overall inflation. Let me stop here. Thank you very much, and looking forward to taking any questions.
Yes, are there any questions from the audience here directly? If not, then let me maybe ask you one question first directly. About the non-linearities, have you also looked at energy price decreases and not only increases? Do you expect there to be any differences, for example?
Yeah, it's an important question, so thanks for that. The framework we use, or what I showed you, was for exactly positive changes and where all those non-linearities are present. But we can look, of course, also at energy price declines. And we do see those non-linearities. And that's actually quite important because sometimes when we think of the recent period, we think of the energy price surges that we saw initially, notably 2021, 2022. But then also inflation came down quite strongly and energy prices came down quite strongly on the downside in the following years. And that's actually what we saw also just looking at the distribution of energy prices. There were very large surges on the right-hand side of the distribution. But also then the subsequent declines were quite sizable. It's important to look at both sides of the distribution.
Thank you. We have a question by our Governor, Holzmann.
Thanks a lot. My question is less on the technical side, but something more on the political and policy side. The typical discourse so far we had often in Europe is when the Russian aggression happened, inflation started. Your data shows very clearly it started already the price increases in 21 as it emerged there. My question is whether in order to make the point, have you investigated how much the Russian aggression added to the price change? Because if we had most of the price changes before, then I would claim most of the central banks were late in reaction to the inflation shock that we had only since the early months of 2021. Thank you.
Thank you. We do take some look at both the distribution over time, and also at changes across different sources of energy. One thing we observe, indeed, energy prices start rising in 2021. That's initially driven quite a bit by oil prices that started picking up quite strongly, while other energy sources partly reacted somewhat later. In the paper, we do look a little bit, how do these fluctuations across different sources of energy compare over time? What we see is that indeed oil prices started increasing quite a bit in 2021, but the oil price fluctuations were broadly comparable with what we've seen in some past episodes. We could think of earlier episodes of strong oil price fluctuations around the financial crisis or other periods. When we look at other sources such as natural gas, those price fluctuations were somewhat larger than what we had seen in previous episodes. And that also holds for some other energy sources when we look across those different dimensions.
Yeah. Another question which emerged in the discussion is to what extent changes in the energy mixer in major energy consuming areas, particularly China, may have contributed to that. The hypothesis I put and discussed often with my staff here is that the change of energy production from coal to liquid gas in China was a major contributor to liquid gas inflation in China and has there enhanced the speed of it. Have you looked in any of these countries how changes in the energy mix may have perhaps contributed to energy dynamics? And the last one is, are you coming in from the US and are you able afterwards to go for a nap? Thank you. Thanks a lot.
I am presenting from Washington, D.C., so it's a little bit early, but I also took a good night of sleep with an early bedtime. To your question, we don't do a detailed analysis of changes in the energy mix at the country level. What I can say, just comparing, we're doing the paper comparing advanced economies and emerging markets, we do see that energy prices do exert a stronger pass-through in emerging markets. And so to try to understand that a little bit better, we took a look at what may explain that. And one factor is differences in the industry composition. So emerging markets that have a larger share of manufacturing, which in turn tends to be a more energy-intensive sector, tend to have larger pass-through of these energy prices relative to advanced economies that may be more services sector dependent, where energy dependence is lower. That explains partly some of the differences in pass-through in the cross-section of countries.
We have one more question back there.
Yes, hello. Yes, David Marsh. Yes, I've got a question which follows on directly from Robert Holtzman, and is really about the feedback loop into policy, particularly if you're now in the United States. Have you factored in anything like releases from the strategic oil reserves of the United States? Yesterday, hearing from Hugh Pill, he was telling us that central banks these days start to think about the what-if questions. So I think this hypothesis and these scenarios are allowable. Does that come into it? And also following on from what Robert was saying about the energy mix, one of the few interesting points that Angela Merkel makes in her recently published memoirs, she actually says that, of course, Mr. Trump in his first term was offering lots of liquefied natural gas, but it was turned down by Germany, A, because they thought the Americans were being very nasty to them and rather mercantilist, and secondly, because it didn't fit in, they thought, with their climate goals. So again, these are quite extraneous questions, but does your model allow such things to be fitted in?
What an empirical approach does is basically take as given what's happening to energy prices at the country level. And so to an extent that they may indirectly account for some of those structural changes that are going on between countries, or some structural differences as well. Think of differences in the energy mix that may affect the extent to which energy prices increase in different places. And we may wonder some of this could be endogenous or could be a response. So then that could contaminate some of our estimates. That's why we try to rely as well this instrumental variable approach, where we use oil supply news shocks. And so that basically takes as given, tries to identify changes in oil prices around major announcements in a very tight time window, to capture basically news on oil supply that's isolated from changes in oil demand, other energy demand, aggregate demand, or other factors that could contaminate this. So that's how we try to address some of the concerns we may have on just using energy price inflation as a measure of energy price changes.
Thank you so much. Are there more questions from the audience? I think we have time for one more. Otherwise, I thank all the presenters and also Thomas now for great presentations. And yeah, thank you so much, and see you in the coffee break.
Thank you very much.
So, welcome back. I hope you enjoyed the coffee break. I'm very happy to chair the second academic session of today's conference. I think we have a great lineup of young and talented researchers. What I noticed when looking at all four papers, they all use high-frequency monetary policy shocks, and the presenters will focus, but somehow on different areas of monetary policy transmission regarding credit demand, labor markets, and production networks. We will start first with a virtual talk given by Supriya Kapoor. I ask now, did we already establish a connection to her? Yes, hello, welcome, Supriya. I hope the audio works and you can hear us.
Yes, I can hear you.
And we can perfectly hear you. Thank you. Supriya is an assistant professor in finance at Trinity Business School at Trinity College Dublin, and she's also a research affiliate at the Central Bank of Ireland. Please, the virtual floor is yours.
Thank you so much. I'll just share my screen now. Can you see my screen okay? Perfect. So good morning, everyone, and thank you to the organizers for giving us the opportunity to present this paper on monetary policy tightening and SME credit demand substitution. My name is Supriya Kapoor, and I'm an assistant professor in finance at the Trinity College Dublin. My co-authors, Michael Mehney and Anush Pratap Singh, are research economists at the Central Bank of Ireland. Since my co-authors are at the Central Bank of Ireland, so the usual disclaimer applies on their behalf. Okay, so in the past few years, there has been a return of inflation, and that's mainly due to a cocktail of factors such as, the pandemic, supply chain bottlenecks, pent-up demand, and the war in Ukraine. And as a response, the policymakers or the central banks around the world, including the Federal Reserve, the ECB, Bank of England, almost in an synchronous manner increased their monetary policy rates, thereby implementing contractionary monetary policy. And to just give you a context, ECB had increased its interest rates 10 times since June 2022, with an accumulated increase of about 4.75% in the marginal lending facility. So that rapid increase in, or the rapid rise of interest rates, point towards financial stability concerns, especially for SMEs. Now, when we talk about SMEs, they are very prevalent in Europe, and SMEs are highly reliant. They highly reliant or rely on bank credit for survival and growth. Unlike large firms, they are sometimes unable to issue bonds or raise equity through the capital markets, and this might. And because of that, the SMEs may struggle. However, there might be some SMEs that are able to raise alternative sources of finance. And so that raises an important question that we answer today is, in the current tightening cycle, did SMEs move away from bank credit and towards alternative sources of finance? And if this is the behavior of the SMEs, then it has implications for the transmission of monetary policy to the real economy. And our motivation today is mainly to understand the SME adaptability in the current tightening cycle. It is a source of resilience via financial innovation, or does it create new vulnerabilities? So our primary aim here is to assess the relationship between the ECB's monetary policy tightening since July 2022 and the SME credit demand behavior. And the underlying idea is straightforward, that as central banks increase the monetary policy rates, the bank lending becomes expensive, the cost of borrowing for SMEs increases, and there might be some SMEs that are able to seek alternative sources of finance. Now, we also explore the heterogeneity in the bank credit substitution across various firm characteristics. And we hypothesize that SME substitution behavior is likely to vary across firm size, age, turnover, income and profit generation, and credit risk. And so basically, in other words, there might be some SMEs that are either willing to or able to substitute credit that as compared to their other counterparts. And finally, we also explore heterogeneity across core and periphery EU countries. And we look at these two separate group of countries because they're different in terms of structural, they're different, they have structural differences in terms of their credit markets, financial conditions, etc. And so it's worth looking at the SME behavior, under the tightening cycle, as we believe that the behavior of SMEs financing conditions might differ across these two set of the group of countries as well. So just to give you a quick preview of our key findings, we find a positive and statistically significant relationship between the contractionary monetary policy shocks and the likelihood that an SME would move away from bank credit and towards alternative sources of finance. So when monetary policy tightens, SMEs become more likely to forego bank loans and in favor of other financing alternatives. So our results are also heterogeneous across different firm types. We see that there's especially for firms in terms of turnover, age, size, and credit quality. So in other words, firms that have higher turnover, are older, are larger in size, and are relatively safer would actually increase their credit substitutions more towards alternative sources of finance and away from bank funding. And then we also find different patterns in the core and periphery countries. So in our sample, we see that the core country SMEs, the substitution behavior is especially sensitive to firm age and turnover, and for periphery countries, this is more sensitive for turnover, company size, and credit quality. So in terms of the literature, so our paper looks at 3 strands of literature, the first being the SME credit demand substitution. And in this, our paper follows seminal papers, including Meltzer from 1960, where when banks tighten lending, the firms may turn to alternative sources, including trade credit. There are also recent papers that we follow in terms of, for instance, Hoffman, Bongini, and Pedro from 2021, and they confirm SMEs' vulnerability to bank credit supply shocks. The next strand of literature that we follow is on monetary policy shocks. So in this, our paper closely follows Jude et al. From 2024. It's a recent paper that also look at the current tightening cycle. And they find that with the recent interest rate hikes, there were some firms that continued with funding access through bank loans. And then finally, our paper follows the firm heterogeneity literature, looking at firm heterogeneity across size, age, turnover is has been an important characteristics. They've proved to be important characteristics in the literature, and they do the financial behavior of firms vary with these characteristics. So, for instance, younger firms or smaller firms might have difficulty in accessing financing conditions, sources of finance as compared to the other counterparts. So our contribution is basically to bring all these strands together, and in the context of euro area in the current tightening cycle, providing new evidence on SME financing behavior and its implications for policy. So in terms of the data sets that we use, our main data set comes from the survey on the access to finance of enterprises. Now, this is a very rich data set available on a biannual basis. It is a firm level survey covering many aspects of firms' financing conditions. So we find information on, of course, firm characteristics, but also on financing needs, their access to finance, and firms' financing conditions. Now, we only look at SMEs, so we exclude any firms that have based on the number of employees, if there are greater than 250. So we only include firms that have number of employees less than 250. Then our sample covers time period from April 2015 and March 2023. So there are 2 things that we do here. The first is we take into account the expansionary monetary policy period from 2015 half year 1 and then 2021 H2, and so that there's a good comparison with the current tightening cycle, which starts in 2022. And then the second thing that we do in terms of our sample period is we exclude the COVID-19 period, so from 2020 H1 to 2021 H1. And the reason is there was so much of uncertainty and large fiscal support programs during this period, which could confound to the normal credit behavior. So we exclude that. And in terms of the euro area countries, we include 12 euro area countries, so we only include those countries that report in every wave. There are some countries in the survey that report every second wave, so we exclude those countries, and as a result, the pool of countries that we have, you can see that on the slides, from Australia, Belgium, Germany until Slovakia. So in terms of our main dependent variable, we construct our bank credit substitution as a dummy variable, and it equals to 1 if the SMEs or firms say that or declare that bank credit is a relevant source of finance for them, but in the past 6 months, they actually do not use bank credit or they do not apply for a bank loan, and instead they use alternative sources of finance, including internal sources, grants, overdrafts, trade credit, and other minor sources of finance. So that's our bank credit substitution dummy variable. We also include a small number of cases here when the firm rejects bank credit on the account of it being only partially granted or it being expensive. So there are a small number of cases where firm actually rejected bank use because they were not given the 100%, they were not sanctioned the 100% amount of the loan, they were partially approved, or they thought that bank loan became very expensive at the time of the approval, and instead they used alternative sources of finance. So this is just an intertemporal graph for our bank credit substitution variable. So on the left hand side, we see it shows the trend of our bank credit substitution variable, and we see that there is a credit demand substitution that increased to over even 40% after the monetary policy tightening. And then on the right-hand side, we divide that based on core and periphery countries. So the ones in red you can see are for periphery countries, and the one in blue on the right-hand side of the graph are for the core countries. And we see that there's a steeper increase in bank credit substitution for periphery countries there. Next, I just want to talk briefly about the summary statistics that we have. So if you look at the table here, we've again divided this table. We've looked at the summary statistics in the expansionary period versus the contractionary period. And if you look at the categories of annual turnover from age, company size, we see that they are mostly homogeneous across both monetary policy regimes, so across the expansionary as well as the contractionary monetary policy period. But if we look at the income or profit category, so we see that the proportion of firms that reported that the income and profit generation increased during the contractionary monetary policy are much lower than the proportion of firms that reported an increase in their income or profits during the expansionary monetary policy period. And then again, this is just a continuation of the summary statistics table. And again, here, if we look at the labor cost, so again, the proportion of firms that reported an increase in labor cost during the contractionary monetary policy is much higher as compared to the proportion of firms that reported an increase in labor costs during the expansionary monetary policy period. So the next thing we look at is our explanatory variable, which is the monetary policy shock index. We follow the high frequency identification approach by Nakamura and Steinson from 2018. And we use the Euro area monetary policy event study database by Altavilla 2019. And we compute the first principal component of changes in risk-free rates, the OIS rates, of various maturities ranging from 1 month to about 1 year, which is observed across a narrow window around each ECB Governing Council meeting or announcement. And thereafter, if we see here, if we separate the pure monetary policy shocks from the central bank shocks by extracting the negative correlation with the stock market index, EU Stock 50, as you can see in the figure on the left of the slide, you'll see that the bars in blue are the pure monetary policy shocks, whereby the positive bars are the contractionary monetary policy shocks here. So importantly, the contractionary monetary policy shocks are instances when the policy announcements regarding the rate changes are higher than the stock market expectations. So in terms of the identification strategy, we employ the linear probability model. This approach is straightforward, and the coefficients can be read as percentage point changes in the probability. So our dependent variable is the bank credit substitution. We take both the contemporaneous and the lagged pure monetary policy shocks. The firm level characteristics are turnover income, firm size, age, and credit risk. And the bank, we also control for banking sector. So in terms of the rate of change in bank lending to NFCs, net interest income, and return on equity. And then we also control for macroeconomic factors, including unemployment and inflation. And importantly, we include fixed effects in terms of country time fixed effects to control for any broad factors that vary across countries over time. And this is just in the latest specification, we now introduce the interaction term between the monetary policy shock and the firm characteristics. And the coefficients on these interaction terms will tell us about the effect of policy shock, or how the effect of policy shock differs for, say, a medium versus a micro firm. So very quickly going on to our results now, the baseline result, this slide presents our baseline result here. So in our regression here, the main coefficient of interest is the lagged monetary policy variable, and we find a positive and statistically significant coefficient on the monetary policy indicator. And to just give you an economic meaning to this, so a unit policy, 1 unit policy shock was basically associated with about 3 percentage point higher probability on the SME being SME substituting or switching away from bank credit and towards alternative sources of finance. And here we look at the heterogeneous response to monetary policy for turnover, income, size, age, and credit quality very quickly.
Supriya, I'm so sorry to interrupt you. Just time-wise, I'm not sure if you noticed the chat, but would it be possible to conclude like in the next 2 to 3 minutes, please?
Absolutely.
Thanks a lot.
Yeah, perfect. So just in terms of our main results here, if you look at this, our results are so firms with higher turnover, larger firms with older firms, and with relatively safer firms are able to switch away from bank credit. We also do this distinction between core and periphery countries. And then finally, we run a battery of robustness checks, including we take an alternative measure for monetary policy shocks as the change in average 12-month Euribor. We also take into account only internal sources of finance, because that's the most cleanest source of finance with no outside market conditions involved there. And then we also take sector wave fixed effects. So yeah, finally, as a conclusion, our research looks at the impact of ECB's current tightening cycle on the SME financing behavior. We show this that we show that the adaptability is actually uneven. It is primarily the large, older, and safer firms that manage to switch away from bank credit and move towards other alternative sources of finance, effectively insulating themselves from interest rate hikes. In contrast, the more constrained SMEs remain dependent on banks and thus are more exposed to the policy tightening. So our study contributes to the literature on this monetary policy transmission and SME finance. It documents the demand side channel, and our findings underscore the monetary policy tightening does not affect all firms equally, and the heterogeneity can inform more targeted and effective policy responses. Thank you very much for listening, and I'll be happy to take up any questions.
Thank you very much, Supriya. Let's give an applause. I think time-wise, we have time for 1 or 2 questions. Is there anybody in the audience with a question? Yes, please. I think Stefan was first.
Yes, hello. Thank you very much. Very nice presentation. I have 2 very quick questions regarding the information you have on the firm level in SAFE. I mean, from top of my head, I don't recall what exactly you can extract from the survey, but I was wondering, do you have a chance to also dive a bit into what kind of credit firm, or what firms actually use credit for? I can imagine there are very different means or ways in terms of how SMEs rely on credit. Is it rather short-term funding, working capital funding, or is it more long-term funding, given that they probably have limited access to bond markets, etc.? So I was wondering, is there any information you can extract and probably dive into? And then the second question really quickly, I think you mentioned at the end that this is a bit more like the demand side view, but I'm wondering whether you could still, so to say, somehow take into account or control a bit also on the credit supply side, so on the banking side. I saw you have a country level control for the banking sector, but I was wondering, given that SMEs usually have very specific links to the banking sector, usually they have one house bank that is, so to say, providing lending or so, and then of course it matters how the bank itself is affected by monetary policy, so how the credit or the bank lending channel, so to say, plays out, and that drives probably also a bit the decision to switch and so on and so forth. So I was wondering, I know there are papers where you can link the firm to the bank directly, using the identifiers, for instance, if you use BankScope or Orbis and so on. So I was wondering if you could do something similar here as well, to just isolate a bit the supply effect a bit more carefully. Thank you.
Perfect. No, thank you so much for both the questions and comments. I think they're very helpful. To answer your first one, I'm not sure if they have information on the purpose in terms of like where they're using for what project, but I could look. I think there might be some information on whether this is a short-term use of it or a long-term use of it, or more of a working capital aspect. So we could look at that. I think another way, I'm not sure too, is did that question refer mostly because you want to see if this substitution effect was more of a short-term or a long-term substitution effect?
Yes, exactly. So just to understand a bit also what kind of credit firms rely on, and that may depend on, or the substitution effect may depend on that quite heavily, no?
Perfect. Yeah. No, we could look at that and see if there's any further information in the SAFE. I know that there's no information on the purpose of the loan, but probably on what you're referring to. And then in terms of your second question, I think that is a great idea. We try to merge. I think one way we can control is to match the SAFE data with Orbis. I'm not sure if, but we can look into this in terms of if the two data sets would talk to each other, and then we can look at more how this channel is influenced with also the supply from the banks. So thank you.
Thanks a lot. Is there a second quick question? Yes, please.
Yes, my question follows on very directly from that last one about the supply. Your data seems to presuppose that all banks are good and that they're doing this for good reasons. Some of the banks will put the creditor in against people who are much more expensive. It doesn't always imply that the other people are going to be cheaper somehow. Some banks are very badly run as well, and therefore, I think in order to make this relevant to the debate about building a capital market union, one does want to have a greater degree of granularity about the alternative sources. And then secondly, I would query whether it was right just to take out the COVID period, because surely that has led to all kinds of dislocations in the supply of credit. Some of the government credit schemes are still running on, aren't they? Some have been very badly handled, some have been fraudulent. So I just would say that somehow you need to take that period into consideration, because for all kinds of reasons, good and bad, that period must still be distorting the data as a kind of tail event afterwards.
Okay. No, absolutely. No, thank you for your comment. We do, I think, it's not, I think it's not in the paper, but we did towards the start when we were doing our preliminary analysis, we did take that COVID period into account, and then we took it out because of this. But I think we can show that still as a robustness check and include that.
Okay, thank you, Supriya, for calling from Dublin and your presentation.
Thank you so much. Thank you. Thank you so much.
Thank you. Now, we don't have to call Washington again. The International Monetary Fund has come to us. Please welcome Rui Mano. He is the Deputy Division Chief in the IMF's Research Department, and he will talk about monetary policy under labor market power. Please, Rui, the floor is yours.
Okay. Yeah, so my name is Rui Mano. I'm not the IMF. So yes, but I did come here. I'm very happy to be here. It's been a wonderful set of sessions. I'm going to present joint work with Anastasia, who's at Bern, University of Bern, Yannick, who's at the Federal Reserve Board, and Anke Weber, who's at the IMF as well, so the usual disclaimer applies. So I'm going to talk a lot about, this presentation is going to be a lot about labor markets, and in particular, I'm going to talk a lot about labor market power. As you can see, it's also in the title. So what do we mean by labor market power? So for those that are not so familiar with this literature, another way of calling it could be monopsony power. So it's essentially the idea that firms may have bargaining power over workers to an extent that they are able to set wages below the marginal product of labor. Because in a perfectly competitive market, of course, wages would be equal to the marginal product of labor. And there's recent work for the US that has estimated that this wedge or markdown of wages is about 30%. So it's quite high. Now, where do these wage markdowns come from? There's kind of a very long literature that we call classical monopsony or labor market power, which says that this markdown comes from the fact that firms exploit imperfect substitution across markets. So it could be because of skill requirements, for example. It could be just because actually workers have a preference to, for example, have a job in the center of Vienna versus in the suburb of Vienna, and therefore firms in the center of Vienna can exploit that strong preference and pay lower wages. So things like that would be called classical labor market power. And there's some citations going back all the way to Robinson on this area. There's a second literature which relies on a very different explanation of where this wage markdown would come from. And it's actually based on search frictions. So in the first explanation, there's nothing about employment. Actually, you wouldn't need even to have unemployment to generate a markdown. This second literature relies on the fact that the matching between workers and firms is not immediate. And therefore, workers, when they apply for a job, they're uncertain if they'll actually get it. And firms that are quite good at matching, so firms that have a good, in this literature it's called the matching technology, they can actually exploit that advantage because essentially they're giving value to workers by offering a more certain job prospect. And so they can actually offer lower wages because of that. So there's kind of two ways that they can offer value to workers. One is a more certain job, the other one is a higher wage. And they kind of trade off these two. So that's a very different logic, and there's also papers, classical papers going back in the literature. So why is it important, and why am I talking about these two sources of labor market power? Well, the first source of labor market power is clearly coming from an inefficiency. And therefore, if classical labor market power is really very prevalent and is the main reason why we have these markdowns, then it justifies a whole series of policy that should correct that, including minimum wage and things of that sort. If search labor market power is really where the markdown may be coming from, then it does not necessarily even lead to low employment. It could even lead to overemployment. And wage markdowns are also cannot be seen immediately as signs of inefficiency. So it's quite important to differentiate these two. So that's exactly what we're going to try to do in this paper. So the questions that we're asking are, what are the macro implications of these two sources of monopsony power? And we look at two areas. One is for the equilibrium relationship between wages and vacancies, and the second is in response to exogenous monetary policy shocks. So that's where monetary policy is going to come in this paper. And in the end, we're going to ask, really, looking at the data, can we say something about which is the most prevalent source of labor market power? And in terms of methods, we're going to construct a model that has both sources of labor market power. So it's a rich environment for classical labor market power, and then it includes also a simplified directed search mechanism to have also the search monopsony. And so it's, to our understanding, is the first kind of macro framework that has these two sources of market power and can generate predictions for what could be driving the markdown and employment. And then empirically, we're going to use vacancy level data from the US, online vacancies from Lightcast to really test the predictions of the model. So in terms of findings, again, we have these two parts. So for equilibrium wages and vacancies, what we find is that vacancies of firms that account for a greater share of local labor market have lower wages, which is consistent with search labor market power. So a lot of vacancies, low wages. It's not consistent with classical labor market power, which would suggest low vacancies, low wages. And then you can compute a back of the envelope that at least 55% of the cross-firm variation in markdowns is actually coming from cross-firm variation in this search labor market power. So it's at least the majority of the variation is coming from search labor market power. Then in terms of monetary policy responses, we show that the labor market power strengthens the labor demand effects of monetary policy, which is actually consistent with search labor market power and not with classical labor market power, which would predict that actually that would be a dampener to the transmission of monetary policy. And these effects are stronger for non-skilled workers. Okay, so I'm not going to go over the model because of the time constraint, but I'm going to give you some kind of intuition and a few charts, a few diagrams, so that you understand the difference between these two types of monopsony power that I've been talking about. So take first classical monopsony. Basically, the whole idea of that literature is that firms that have classical monopsony face a steeper labor supply. And so following basically a demand shock, you could think of monetary policy loosening as a demand shock, basically classical labor market firms would hire less relative to those that don't have this labor market power. So essentially, in in blue, you have a firm, let's imagine that this is the labor supply facing a firm that doesn't have classical monopsony. It's a more elastic labor supply than the firm that is in black, which faces a steeper labor supply. So when you have basically a demand shock pushing out wages rise, but then for the firm in black, labor rises less than the firm in blue, which is in the x-axis. So higher classical labor market power, when you have more, an expansionary monetary policy, you're going to hire relatively less. Now, what about this directed search mechanism and search monopsony? So now, instead of just posting wages as the only lever that firms have to attract workers, they now have two margins. They could post more vacancies, or they could post higher wages. And basically, as I mentioned before, employees are going to trade off a higher wage that they may be offered with a higher likelihood of finding a job. And what we're saying is that we're interpreting this search labor market power as an ability to actually generate more vacancies that are then converted into hiring. So a higher likelihood of getting employment. And so these search labor market power firms will offer essentially a more certain employment prospect to workers, which they value. And so following a monetary policy loosening, a high search labor market power firm is going to actually post more vacancies. So they're going to shift this labor supply curve out. And so for the same demand shock, they're actually going to expand their labor by more than they would if they didn't have this ability to post more vacancies. So these have very different implications, kind of the opposite implication. So we then, in the model, we basically trace out two tests that we're going to bring to the data. The first test is coming from this idea that firms with classical labor market power have lower equilibrium wages and less vacancies. So there's kind of a positive correlation between the extent to which you post vacancies and the wage level. For search labor market power firms, it's the other way around. So for there's actually a negative correlation between the extent to which you post a lot of vacancies and wages. So we're going to see in the data if it's consistent with either of these. Then for monetary policy responses, we have a second test, which is really thinking about what is the response of vacancies and wages to monetary policy. And there again, and I walked you through the logic of the model in the diagrams, we know that vacancies of firms with classical labor market power do not respond differentially or even could respond less than those that don't have classical labor market power, and the reverse is true for search labor market power. So let me talk a little bit about the data that we're going to use. This is Lightcast. It used to be called Burning Glass Technologies. And this is the near universe of US online vacancy postings. So it's about 250 million vacancies for mostly the period following the GFC, and then we cut off at COVID. We don't have anything to say about the COVID period. These vacancies crucially say what is the address at which this vacancy is being offered. So one can create essentially an establishment level amount of vacancies. And so that will allow us to have very fine geographical breakdown that we can then map to labor market, local labor markets within the US. And we have also information about the industry, the occupation, job requirements, and the posted wage for 17% of vacancies only. So there's only 17% of these vacancies that report wages. There's a paper that shows that there's no particular concerns about selection between the 17% that have wages and the rest that don't report wages. And then for monetary policy shocks, I'm actually going to rely on the previous speaker who went a little bit into this idea of how to separate pure monetary policy shocks from central bank information effect. So we're using Jarosinski-Karady, which is another method to get at the same issue. And we're going to control for this information effect, but focus on the pure monetary policy shock. Okay, so what are equilibrium vacancies and wages that we're going to look at? So we're going to first define a vacancy share. So it's the share of vacancies posted by a single firm in a local labor market. And these are going to be commuting zone, US commuting zones. And we're going to use the cumulative share. So to avoid, because firms don't post vacancies every quarter, this is a quarterly data set that we construct. Some firms may not post every quarter, so we want to capture somewhat the idea that they're posting, what is the extent that they're posting in that labor market for a period of time. And then for wages, we do kind of a similar logic, so we do cumulative wages, but there we purge wages from occupational and local labor market effects. So occupation time and commuting zone time effects, so that we're not capturing, for example, that one day you're posting an accountant and the next day you're posting a janitor. So we're accounting for that, so we're not comparing wages across different occupations. So just in terms of a chart that shows the vacancy share, it's called, I made the mistake of calling it market share, it's a vacancy share. And you can see, and this separates for non-college workers and college workers, and the wages on the y-axis. So what you can see is as the vacancy share rises, actually wages decline for both categories. And this would be consistent with search labor market power, which predicts exactly that. It would be, classical labor market power would predict actually the opposite. So a positive relationship. We do a formal test with vacancy level data. I'm not going to go into it. Then we look at monetary policy responses. So here we basically run like a series of 4 regressions where we, on the left axis or on the left side, we have either log vacancies or log wages. And then we have for firm I in commuting zone C at time T. And the coefficient of interest is the relationship or the elasticity of monetary policy interacted with equilibrium, either equilibrium vacancies or equilibrium wages. And I mentioned that we're going to control for the Fed information effect and its interactions also with the equilibrium vacancies and wages. And we have commuting zone time fixed effects that absorb, like, for example, local demand shocks, so things that you would be concerned about in running a regression like this. And we have also firm fixed effects. So the test that comes out of the model says that if really search labor market power is key, then you'd expect the coefficient on the top regression to be positive and the coefficient on the second regression to be negative. And if you're concerned about confounding effects, you actually want to find 0 effects for the other 2 regressions. So for example, if there was some kind of, if I have more labor market power, but I'm also more productive or less productive, that could lead to differential effects in terms of wages that would not be because of labor market power, it would be because of these other characteristics. So you actually don't want to see that. And that's exactly what we find. So 1, 2, 3, 4 are the 4 regressions that you just saw. We find that if you have more, if you account for a greater share of vacancies, you're going to react more to monetary policy by posting more vacancies. And you're going to actually reduce your wages, or in this case, raise wages if we're doing loosening of monetary policy. So you raise your wages by more. So that's consistent with search labor market power. You'd expect either the reverse or 0 effects if classical labor market power was there. Okay. Just to say that we did something with employment to show that actually this carries through to employment. So this is not just about vacancies. And we do a lot of robustness, just to list a few. So we look at impulse responses, We use a richer set of fixed effects, including, for example, exploiting just variation within the same firm, posting different vacancies across different labor markets. We look at different wage measures and a few others. So let me conclude because I think I'm completely out of time. Yeah, I see the 1 minute. Thank you. So there's two reasons why this labor market power may arise. We call it classical labor market power. It generates markdowns that are inefficient and also inefficiently low employment. And this has been like a big concern of policymakers, and it has justified the imposition of minimum wages and other policies that basically make firms essentially have to increase their employment beyond what they would prefer. Search monopsony is different in the sense that that it can lead to actually efficient outcomes or partially efficient outcomes, and can even generate too much employment. So there could be in a situation where the markdown is inefficient, but there's too much employment. It's too much low-paid employment, by the way, to be concrete. And so what we're trying to do here is we construct a framework that allows you to think about these two, and then we use very rich data for the US to test the two, and we find that this search labor market power is at least as important as classic labor market power, which has received considerable more attention in the literature than search labor market power. So I'll close here. Thank you.
Thanks a lot. Interesting work and a great presentation. So, first question by Birgit.
Really interesting paper. I'm not familiar with the literature, so please excuse if I ask something which everybody else knows. I mean, first of all, labor market power actually means employers' power here. Yeah, maybe the terminology would be clearer. But on the other hand, employees also have some skills, features, characteristics which may pose rigidities to the employer's side, so that they prefer to stay with somebody because of some special reason that, yeah, whatever. Is the literature on this, do you incorporate this to this, or is this not important when looking at monetary policy shocks?
Could you tell me more about the rigidities that you have in mind, just so I understand?
I mean, for instance, one clear rigidity is that sometimes, I mean, we are now coming out of a time of labor hoarding, yeah, and this was due to the fear of employers that they would not easily staff in case the economy starts kicking in.
Right. Okay, perfect. So, first, on the terminology, yes, that was one of the first things I said, because I know this generates. So it's in the literature. People have called it labor market power. Another way is monopsony, but you're right. And it's all about the relative bargaining power. So what we're seeing here is that for these firms that we're calling that to have this monopsony power, they have a relative higher bargaining power versus workers. It's not saying that workers have no bargaining power. One thing that I didn't show, and I think speaks to also to your second part of your question, is that when we split vacancies by requirements, and in particular education requirements or some skill like software skill, for example, if you need software skill, we find that this effect is actually driven by low-skilled work. So to your second part, I think like this points about, well, maybe labor, essentially, if I'm hearing you, you're saying the bargaining power of workers may have risen because of tightness in the labor market, in post-COVID labor markets, which I think is very reasonable. What we're showing here is that a lot of these effects are more on the low skill side, which is where you would expect actually workers to have less bargaining power.
Okay, thanks a lot. Is there a second question? Yes, Philip, please.
Thank you. So if I understood the mechanism correctly, is that you have a shock and then you want to adjust employment, and you do it on the margin of vacancies instead of wages, because you or the firms can more easily attract workers that are trying to find a stable or more certain match. But I mean, you didn't go so much into detail of the model, but how do you think about this in more general equilibrium? If labor is fixed, wouldn't then more vacancies also make the market more tight and also reduce the probability of forming a match.
So in our model, indeed, the amount of search is kind of fixed for the total search done in the market. So we have this concern, and then we solve for general equilibrium in terms of the equilibrium wage, the equilibrium vacancies of each firm. So I'm not sure what you're exactly trying to get at, but essentially you can think of it like this, that the share of vacancies is moving across time. So the relative share of vacancies across firms, which shocks, and then which firms are more prevalent in different points in time will depend. If you have a positive shock, like this monetary policy loosening, then these high labor market power firms that have search labor market power will account for a greater share as opposed to all others. But when there's a negative shock, it's the reverse effect. So they'll account for a lower share. Did that answer your question, Philip?
Yes, just a follow-up. So then the amount of total vacancies posted is constant?
In the model, yes.
Okay, that explains sort of what I was asking.
So it's all about the relative. So this is not a model about the total, basically the average. It's about cross-firm.
All right, now I understand. Because if there was an increase in vacancies, then the tightness would increase and then also lower the probability of...
Yeah.
Yeah, but I understand now the framework. Okay, thank you.
To be clear, in the data, of course, total vacancies vary, and that's why we focus on the share to pin down the relative market power.
Okay, thanks a lot, Oe, again, for the interesting presentation. We are also continuing. Mr. Clark again. Let's continue with some other work on the labor market, this time connected to the bank lending channel. Please welcome Ahmed Ali Taskin. He's a senior researcher at the Institute of Employment Research and also is teaching at the University of Erlangen-Nuremberg. Please, the floor is yours. We're looking forward to your presentation.
All right. Thank you very much for including me to a very interesting session. I'm having the benefit of many of the audiences attending the previous policy sessions and also my colleagues presenting some of the things that I'm going to present on my behalf. So I'm going to benefit from that angle. This project is a joint project with colleagues from RWI Essen and FU Berlin, Britta Gerke, Marvin Nöller, and Ahmed Balir. And so we are, this is my second time presenting it, and we are pretty much trying to document all the outcomes of monetary policy from the perspective of the firm and how labor adjusts in terms of inflows and outflows. And we are trying to see to what extent bank lending channel, and I'm going to be more specific on that later, to contribute, that contributes to this adjustment. Okay. All right, so the ultimate question that we are at is when how does monetary policy affect the labor adjustment of firms from variety of angles? So we have a firm perspective. This is one of the things that we differ from the previous literature. And we would like to know, on top of that, we would like to know, since we have the firm perspective, to what extent firms' access to finance or access to available finance through bank loans matters for this adjustment. So I'm just going to give you all the findings that we have so far, so that you don't think about it later, or you think about it with context. As expected, monetary policy indeed affects employment. So it works very nicely. Following especially a contractionary monetary policy shock, we find that employment declines at the firm level. And this is especially strong, if anything, maybe it's only the part that is significant when the bank lending channel bites. So for those firms that are linked with some weak banks, this reduction in employment is particularly higher. The second thing that we do, and this is the main contribution of this work, with the help of good administrative data, we can decompose of these employment into flows from the perspective of the firm again. So we find that after following a contractionary monetary policy, the employment falls, and these falls come directly from the decline in inflows. Outflows actually decreases more often than not. So we find that the majority of the decline in employment is coming from inflows, and this is tightly related to bank lending channel. Outflows, on the other hand, declines, and it declines less for firms with good banking relationships. Finally, we do another decomposition into the within firm wage distribution, and we find that the decline in inflows, for instance, is particularly high for low-wage workers, so people stop hiring low-wage workers following a contractionary monetary policy shock. On the other hand, there is labor hoarding. And without further ado, let's see how these things come into being. In order to get these results to happen, we need to link a variety of data sets into one working data set. For that, we are going to combine the monetary policy surprises that has been introduced already with a data set of workers, firms, and banks in Germany. And then we are going to propose a decomposition of the firm-level employment flows based on the within firm wage distribution. And we are going to do this an analysis within the context of dynamic local projections model. And when we say bank lending channel in this presentation, I'm going to be specifically referring to the variation in bank equity, which we are going to compute based on relationship banks of the firms that we have in our data set. All right, so obviously we are not the first one to do this type of an analysis. There are several literature that we contribute in that perspective. So there are several papers from the perspective of the individuals, oftentimes, but also at the firm level, that look at the employment effect of monetary policy. Bahaj and Jasova to count some. But also, there are some recent literature that looks at the flows of individuals following a monetary policy shock, but that's not at the firm level, at the individual or aggregate level. And another literature that is of interest to us is the general literature of financial constraints and how monetary policy gets in the way of transmitting those to the firms. So there is a large literature on investment, small literature on employment, and also overall credit supply shocks that affects labor market outcomes. Finally, from the perspective of within firm wage distribution, we are looking at the inflows and outflows of low wage and high wage workers, and that's going to contribute to the discussion of monetary policy and income distribution. All right. So, as I said, we are going to link a set of workers, firm and bank level data sets. In order to do that, we are going to use DAPHNE, which is a German version of Orbis, so that has the financial accounts for public and private firms in Germany. On top of that data set has dynamic relationship bank information, which needs to be linked to a balance sheet data, which is bank focus. Dynamic in the sense that we also account for mergers and acquisitions in that perspective. And one caveat of that is these are relationship banks. We do not know to the extent of loan amounts in any way. So we are skipping to the real effects directly in our analysis. And with this combined data set, we have to merge it with the administrative data, which is the integrated labor market biographies. So we know all the people that are subject to Social Security in Germany. And so this is the Institute for Employment Research. This is our bread and butter. And we know exact date of employment and exact date of flows to non-employment. And based on that, we are going to create firm-level total employment and flow measures at the quarterly frequency. And finally, this data creates about more than 200,000 firms that are linked with close to 2,000 banks, which is a feature of banking system in Germany, close to Austria, as far as I understand. So there are lots of small banks in Germany in the names of savings banks and credit unions, and also a handful of very large banks. So, how do we get to find this, the results that I mentioned? So I'm going to show you two empirical specifications. The first one is just to motivate, to ease out the second, the final model that we have. I will have only one slide that I show you an average result. Otherwise, the rest of the presentation is more about the second empirical specification. So you see that the outcome, this is a local projection method that many of us has been using these days, thanks to the innovation of Jorda and later contributions. So this is at the firm level, and we are looking at the firm level outcomes from the perspective of the relative period T-1, following 8 quarters at the moment. Most of the outcomes that I'm going to present today is going to be consisting of employment, but I will start with what we call wage sum, just to tease out some of the mechanisms already, and then convince that the employment is the channel that works much more with respect to the monetary policy shock. The variable of interest is the monetary policy. This is coming from the Jarodzinski-Karady shock, so you all know what it is, and I should not tell you much. Instead, on top of that, we have the firm fixed effect that accounts for like a higher volatility of employment or flows at the firm level, and also to account for seasonality, we have the quarter fixed effect and some control at the aggregate and firm level time variant. All right, so let's get to the main content. So the title of this presentation is about the bank lending channel, so I'm going to give you a very brief overview. I'm assuming that the audience knows more than I do, so I'm not going to spend a lot of time on this. So the bank lending channel has been coined almost 40 years ago, and this has been basically says that the credit supply, the bank loan supply matters in the workings, in the transmission of monetary policy. So we're going to be very specific. Empirically, one of the ideas that is linked with the bank lending channel is that bank balance sheet constraints amplify the transmission of monetary policy. So far there has been many elements of balance sheet, bank level balance sheet that are suggested for this transmission. We are going to take bank equity. It works from our experience. It works the best for the most of the analysis of previous literature, and also it has the precise meaning that following any shock to a bank, the bank equity itself is a cushion against to survive adverse cash flows. So previous literature have shown that the well-capitalized banks borrow cheaper and also shield their lending from any shock. In order for this to work, we have some identifying assumptions. First of all, it needs to work in the sense that following a monetary policy shock, lowly capitalized banks reduce credit supply by more. So we just take this from literature. We are just going to jump what's going to happen to labor market outcomes. And well, it needs to be the case that the firms cannot really move from one bank to another very easily. Otherwise, this would have been easily overcome by alternative sources of funding. So the funding opportunities are linked with the relationship bank. And finally, which is the most difficult one, the types of firms and the types of bank with regards to its match is not endogenous to the workings of the monetary policy. So I'm not going to spend a lot of time on these things, but you should know that under these assumptions, this story works. All right, finally, this is the final model. I'm going to introduce just one more element basically here, which is the element of the interaction of monetary policy with a bank level balance sheet. And throughout the presentation, what I have is a distribution of bank equity of relationship banks quintile. So basically, for any given time, I compute the bank equity of the firm's relationship bank, and then report whether that falls within the lowest quintile of distribution or the highest quintile of distribution. So we're going to compare the top and the bottom. For this presentation, we are going to focus on multiple banks, multiple bank firms. So this comes from the reasoning that the relationship bank information does not necessarily entail whether the firm has a loan relationship with this bank, but the literature has already shown that multiple bank firms often do this for land borrowing purposes. Moreover, the fact that you belong to the highest or lowest quintile of the bank equity distribution is further reinforced for multiple bank firms. One may also further control for other factors that account for heterogeneous demand with regards to this distribution, so industry time and location time fixed effects. Most of the presentation does not have this, but I'm going to present at least one table for that. All right, so think about following a contractionary monetary shock, what happens to total flow of wages at the firm level. Well, following this, the demand declines, and also the firm is experiencing, all right, the firm is experiencing the decline in the decline in cash flows. Because of that, the firm decides to lower its wage sum. So following a monetary policy shock of 2 standard deviations, so that's about 10 basis points, the decline in wage sum comes about 1.5% by the sixth quarter. If you decompose into employment and wages, you see that the highest decline is observed in employment, which is what we are going to focus throughout the rest of the presentation. Wages are obviously more rigid, and the response comes later, and it's less significant. And we are on the way of producing further results later, but not for today. All right. Finally, you can think of employment as the changes in employment as a composition of flows and inflows and outflows. Following any event, employment changes by the accumulation of inflows minus the outflows. And now we are going to see how that comes about. So the red line shows you the bank lending channel effect. Basically, it shows the effect of the firms that employment decline for the firms that are linked with weak banks, and the blue line shows you the effect of the firms that are linked with the strong banks. So as you see that in the evolution of the blue line, the red line, I'm sorry, is quite related to the evolution of the first graph that I showed a moment ago, so total employment. So the size is larger, but it starts declining, and it declines quite all the way to the 8th quarter, and it stays there. On the other hand, the decline for the wages of the high equity bank firms is much smaller. It follows a relatively flat pattern, and it's significantly different from the low equity bank firms by the 5th or 6th quarter. We can further decompose that into inflows and outflows. We find that following a monetary policy contraction, indeed, inflows decline, but interestingly, outflows also decline. So this is reminiscent of discussions that we had yesterday. So in a way, firms hold labor following a contraction in monetary policy shock. At the very end of the presentation, if I have time, I'm going to speak a little bit more about this. All right, so let's make another decomposition. Now, we can think about these inflows and outflows from the bins of wage within firm wage distribution. So low wage workers, high wage workers. This is the idea that we have. So if you look at the low wage worker composition in employment, you see that so by construction, these are the numbers are the same. So the levels exactly refers you to the exact effect. So the decline in employment almost exclusively is happening at the very low end of the wage distribution from the perspective of the firm. Moreover, the decline is higher for when the bank lending channel bites, so the firms that are linked with low equity banks. By the time we get to the highest high wages, there is no difference anymore. If anything, maybe the employment is slightly positive following a contraction in the monetary policy shock. This refers that maybe there are some reverse wage channels that are happening that we haven't yet fully analyzed. But you see in inflows and outflows that the decline in the employment for the low-wage workers is predominantly coming from the decline in inflows, whereas the outflows for low-wage workers, especially for when the bank lending channel bites, is constant, and firms try to keep high-wage workers to the best that they can. So the following a contraction in monetary policy shock, it actually declines, the outflows decline. So one thing that has been fully enclosed yet, but we have done some exploratory analysis, is that following a monetary policy shock, the outflows decline. But why is that happening? Then we decompose those outflows into three by different types. First of all, the outcome type, whether the job-to-job transitions are happening or flows to non-employment. As expected, and luckily, actually following a contraction in monetary policy shock, flows to non-employment actually increases. It is the flows job-to-job transitions that decrease. And this decrease is particularly strong for transitions that involve transitioning into high wages. So overall demand, economic activity declines, and through that there is low inflows, and because of that, job-to-job transitions decline. We try to assess the roles of other types of regulations and also other dimensions of labor hoarding. We don't have a conclusive result yet. So outflows by job tenure produces some non-linearity. On the other hand, we observe that for the high-skilled labor, there is a strong decrease for outflows, and this is amplified for bank lending channel by bank lending channel. So the firms that are linked with weak banks, they really try to keep on with their high-skilled labor, especially when other things are not working quite well. So the results are stronger, obviously, for contraction in monetary policy, and very weak for single bank firms. With that, I'm going to conclude. We find that, I hope that I convince you that the contraction in monetary policy shock lead to a fall in firm employment, which is expected, but this is happening through a decline in inflows rather than outflows. If anything, the firms hoard labor, and they try to hoard labor by some sort of skill composition, or some firms, some individuals are valuable to firms. So we would like to explore further with regards to employment protection regulations, whether that comes into effect. We don't see it yet. And the discussions of labor scarcity, especially from the perspective of high-skilled labor, whether that makes a relevant case for the transmission of monetary policy. Thank you very much.
Thanks a lot. And we are looking forward to questions from the audience again. So I think Philip was first, yes?
I have a question about the bank lending channel, and here you sort of said firms that are associated with banks that have a lower bank equity have a stronger reaction to the monetary policy shock. But what if there is sort of, it's not random whether I'm matched with a high equity or low equity bank. Maybe there's some competition about loans, and actually the weaker banks also in equilibrium match with weaker firms, and then you just pick up this sorting in your results. Maybe you can say something about it.
Yeah, very good question. So thank you for that, because we actually indeed find the opposite of what you said. The strong firms are linked with weak banks at the way that we categorize. So if you are a large and old firm, you are most likely to link with a bank with low equity. And if you are a very small and young firm, you are linked with a high equity bank to a certain extent shield yourself from these shocks. So it works against our story.
Okay, very interesting. Is there a second question? Yes, Fabio, please.
Yeah. So I wonder in how far your results are generalizable for market-based finance systems rather than bank-based finance systems. So would it imply that the effects of monetary policy on the labor market are weaker in capital-based systems, which I think empirically it's not what you observe? Or how would you reconcile that?
I think it speaks to the contribution to the literature. So like many US papers using CompuStat data often uses firm level balance sheet variables. It makes sense because it's a market-based system where the firm level balance sheet variables are more important. Here, we think that this is a bank-based system. In Germany, most of the lending relationship, most of the loan, external finance ability is being provided by banks, especially for many small and medium enterprises. So in that regard, it works both ways. It's just that bank-level balance sheet variables are more important than firm-level balance sheet variables in the bank-dominated system. This would be our feeling and observation.
Okay, thanks a lot, Ahmed, again for the presentation. Thanks for the question.
Thank you very much.
Let's welcome. And we now welcome our last speaker, who is Stefan Gebauer. He's a senior economist at the Monetary Policy Strategy Division at the European Central Bank. He's also worked at Banque de France and the DEW Berlin, and he will now talk about production networks and monetary policy transmission.
Yes, exactly. Thank you very much for the introduction, and thanks to the organizers to have our paper taken up in this very nice conference. This is joint work, or the project I'm presenting today is joint work with colleagues at the ECB at the University of Bonn. And as in the cases before, of course, the usual disclaimer at the bottom of the slide here applies. Oops. Yeah, so let me start with the broad motivation of that project. So we started working or looking into the question of that project by starting from two broad observations of two broad fields that we were looking into in recent years. So one development we observed, and that has been very prominently featured also in the conference here, in the panels yesterday and so on, is that production networks are really important factors in shaping the transmission of economic shocks. And the second, so that's something we also on the policy sphere, by the way, have of course looked into in recent years, and that has been a prominent topic over the COVID surge. A more, let's say, timeless and more long-standing observation, more directly related to monetary policy, is that there's now a large literature, both empirically and theoretically, documenting that financial frictions or financial constraints, whatever you want to call it, at the firm level, may act as an amplifier or accelerator of the transmission of monetary policy. In this project, basically, we try to bring together these two observations, because I think when we started looking into the literature, that we've seen that there's a very little discussion about how also the fact that probably you as a firm are exposed to financial frictions that your upstream customers or downstream suppliers across the production network might face has been discussed. So that's what this project here is about. It's mainly empirical, even though at the end I will also present a small model that we have in the paper if time allows. But the empirical question really we are after here is whether what we call, to what extent direct and indirect exposures to leverage that a firm, or in our case then aggregated up to the sector level, a sector might face across the production network affect the transmission of monetary policy. So what do I mean with direct and indirect leverage exposures? So I think the direct exposure or direct effect is something that is more traditional or more classic in the sense of its traditional, let's say, balance sheet channel operating, so that the firm itself, or is then again brought to the sectoral level, a sector itself is exposed to high financial or tight financial conditions, which we proxy here in the terms of relatively high leverage holdings. The transmission of monetary policy is probably amplified through a balance sheet channel. So that's what we think about in the with direct exposures. Indirect exposures are exactly these kind of exposures that exist throughout the production network. So how does the fact that probably you have suppliers that are very highly leveraged affect the transmission of monetary policy to their prices, back to your prices, then throughout the production chain. So that's the broad question we are after. And we try to tackle this by first proposing a new way to measure these, what we call up and downstream financial constraints. I mean, it's a critical word to use, but let's say up and downstream leverage exposures empirically, We then integrate these indicators in the model, and guess what? We're estimating a local projection setup here to study the interaction of these measures with monetary policy and how transmission is affected by these measures. And then, as I said, what we do as well is we try to rationalize a couple of these empirical findings that go a bit under the hood of these, let's say, more traditional balance sheet discussions in a theoretical multi-sector model. But let's see how far we get with that during the presentation. So as I will be mainly speaking about the empirical part of the paper, let me give you a broad overview of the data we use. So in a nutshell, it's a country sector panel for the 20 euro area countries that we're constructing. And the data set is so they're composed of, let's say, 5 building blocks. So one is the first block is very standard. It's just a collection of country-level macro indicators, so you get the full battery of country-specific macro variables that we have in the data set. We have monetary policy shocks, and guess what as well? We're using the Jaroczynski-Karady high-frequency shocks, so very no innovation here compared to the other papers that have been presented. Even though we try to work with other shocks, so if someone from the audience has good proxies for the euro area in particular, we're happy. We're trying to collect a bit of a robustness exercise using other shocks as well. And then what we add is really sector-specific data on nominal and real variables. And that we draw from Eurostat data. There's the short-term statistics data set that provides sectoral data. As was also discussed in one of the presentations in the first session, there is quite good coverage, but there's also a bit of missing elements in some of the sectors. But we still get a quite good coverage with that data set. And that we really are able to sector-specific information at what is called the NACE2 classifications, for those of you who are familiar. So we're able to report for 64 different sectors across countries that information. And the key variables of interest, as you will see in the regressions, are producer prices, so the PPI will be the price measure that we apply in terms of this production network discussion, and we have sector-level industrial production as well to account for real activity. We also add as a fourth element data on input-output linkages, so really the production network. There's also Eurostat data available, these Figaro tables, for those of you who are familiar with that information. That's something we have also at the country sector level, but unfortunately only at annual frequency. So that's something we have to deal with. And then as a fifth element, to proxy our financial measures of the firms, and that we then use to aggregate up to the sectoral level, we rely on Orbis data to really get firm balance sheet information and derive the leverage measures. We have various of them in the paper from really firm level data that we then bring to the sectoral level. Overall, we have a data set that spans the period from 2002. We could even go further back in time, but we conditioned on taking out the earlier years of the European Union up to basically the end of 24. And that gives us approximately 250,000 country sector observations in the total data set, let's say. So with that data at hand, I'll now present you the key econometric model that we're estimating here. And also, as you can see on the slide, I try to really focus on the key, let's say, parts or factors in that model that I want to highlight that are related to the question we address. So it's a panel local projection setup that we're estimating here. So on the left-hand side, you will have sector-specific information. So for instance, producer prices in sector I in country C. And we have on the right-hand side then, if you start with the bottom line of equation 1 here, the monetary policy shock ST directly added just plainly into the model. But then we also add in total 3 interaction terms of that monetary policy shock with these sector-specific leverage measures. So starting now in the first line from the left of the right-hand side, so beta 1 is capturing basically what this direct effect of leverage in relation to monetary policy. So that's something that is more traditionally can be associated with the balance sheet discussion. So if the sector itself is exposed to different degrees of leverage, the transmission of monetary policy may be different. We then add beta, the terms governed by coefficients beta 2 and 3 to the equations, and here we really try to bring in these new measures of up and downstream leverage exposure throughout the network that we construct. And they in a nutshell, one variant to construct, and we also propose different versions of that measure in the paper, but that's the one we use in the baseline specification. You see at the bottom in equation 2, so we have these capital phi and phi tilde here, and basically starting with the upper line capital phi, That's basically if you want a sophisticated equation to give you a weighted average, so to say, of the share of the bilateral exposure of the two sectors in the production network. That's this new parameter here on the right of the equation, interacted or multiplied with the respective sector's leverage holdings. And then you just sum up these weights. So you have, for instance, that a sector I has different exposures governed by these weights nu to other upstream suppliers in the production network, and you interacted with the leverage position of these upstream suppliers, and then you sum up to get an indicator, so to say, of in the top line upstream exposures, and then on the bottom line we have the same measure also constructed for downstream exposures, which is basically the other mirror element in the input-output tables. There's a slight adjustment factor in the beginning of the equations. This is 1 minus a and 1 minus a tilde. They are just there to capture the fact that, of course, some of the inputs and outputs are coming from outside the production network or leaving the production network. So, for instance, there are factors like labor and so on coming from outside the production network, and there's obviously also final consumption, which is then meaning that some of the goods leave the network for final consumption. So we adjust for that. That's also based on the information from the input-output table, so that such that it's really an intra-network exposure that we're measuring here. Of course, we could also report on let's say, what the share that goes to final consumption, etc. But that's not in this variant of the measure now. So in a nutshell, we interact these up and downstream measures in addition to the own sector's measures with the monetary policy shock. And in the next slides, when I show you the results, I will present them in a way that I will first report on the plain monetary policy effect, so let's say the average effect when all these leverage measures are at their mean. I will then show you an IRF that also reports on the additional effect that stems from this total leverage or total financial exposure, which is basically reflected in a linear combination of beta 1, 2, and 3. And then from slide to slide, I will slice down a bit this linear combination to zoom in into these different beta coefficients and show you the impulse responses to dig into the sectoral composition of that exposure. So let's start with the first slide. So here you see the first broad set of IRFs that we were estimating. So the black line here is giving you the average effect, so meaning that all these leverage terms are basically at their mean. And our observation there is that in response to policy tightening shock, prices and output decline in the first 2 to 3 years after the shock. We find, which is also something that is well documented, at least in these kind of models, that activity falls a bit earlier than prices. So there we are saying that the average effect that we get from the model is more or less consistent. Of course, you can have very different results, but with what you usually find in response to a monetary policy shock. The blue line now is, in a sense, the linear combination of these beta 1, 2, and 3 coefficients that I showed you on the right-hand side, and you have to actually add this up to the black line to get the overall effect if you switch on, let's say, this potential amplification effects that you get from leverage positions. And the way the point at which we evaluate these interaction terms here is saying, let's assume that all these leverage measures that I showed you, like the own leverage measures upstream and downstream, increase by 10% from the mean. So it's a relatively large increase, of course, in this scenario of leverage, saying that leverage throughout the whole production network is going up by 10%, but that's basically what you see here. And what you find then is that overall financial, I call it financial constraints here. Again, I'm a bit sloppy on the wording, but let's say financial exposure of the firm, if that goes up, there's an amplification effect through the transmission of monetary policy. And that first observation seems relatively consistent with what you usually find or what many people have also documented in the past. On the next slide now, I will zoom in, as mentioned before, on the blue line that you see here. So remember, this is a linear combination of the beta 1, 2, and 3, and now I will decompose that blue line in what we call the direct and indirect effect, just to give you an idea how relevant these indirect network-related exposures are. What we find here is that, take a look at the price response first on the left-hand side, is that in this estimation, you see it also that the direct effect is important, obviously. It's driving a large share of this drop in the blue line, but also the indirect effects are non-negligible. Again, it's a large increase in leverage that we're reporting here, but still it's remarkable that these indirect effects are significant and also explaining quite a share of the overall drop from financing conditions. Admittedly, the picture on industrial production is a bit more edgy, but also there we see that both direct and indirect effects seem to matter. And that's also something we find throughout a lot of different specifications, being on the financial measure we use, being the different input-output measure we use. Also there you have different ways to transform this information in the input-output table, etc. But that's something we find robustly. So that's the second finding. So it's not only that the financial position itself matters for the transmission, but it's also the fact that also this indirect, let's say, network exposures matter to a large extent in the transmission of monetary policy. Now, in the next slide, I will even zoom in further. So remember that we now disentangled only beta 1, the direct effect from this linear combination of beta 2 and 3 in the equation before. And now I'm also zooming in on this brown line here that you see on the slide, which is giving you this indirect effect, which you can further decompose into what we call this upstream suppliers effect and downstream effects. And that's on the next slide here. So again, the thick brown line is the same line that you saw before and now decomposed. And what you see here is something we found rather interesting, namely that when you look at the price response, you see that there's a diverging effect, so to say, between what we call upstream effects and downstream effects. So it seems to be the case that while overall financial conditions seem to amplify monetary policy transmission to prices, this upstream cost channel that we call it like this, stemming from the fact, from the interaction of the monetary policy shock with your upstream suppliers' degree of financial leverage, seems to mitigate in part this dampening effect on prices. And that's something we find very robustly throughout, again, different specifications, different ways to measure this financial leverage variable in the microdata, different forms of reporting on the production network, et cetera, different estimation, setup of the models, et cetera. So this is a really robust finding. So in that case, we were wondering, okay, what is driving this effect, right? I mean, and we thought our reading of this finding is that when you look at the downstream, let's say the pink or purple line here, perfect. You see that this seems to behave like a demand side story, right? It's really the leverage position of your downstream customers that you interact with the shock from the perspective of sector I, and you're seeing that whenever they are more financially constrained, let's put it like this, the transmission of monetary policy is stronger, which is consistent with some kind of demand story. Whereas the upstream suppliers effect that you see here is probably more related to a cost push or cost channel story for monetary policy, where you say whether in case your upstream suppliers are facing higher constraints, again, if high leverage is your proxy for tight financing conditions, you see that has an upward effect on prices. And by the way, industrial production, of course, now we are also treating, really zooming in a lot econometrically, it's a bit challenging to estimate, but you see that you also get a drop in the green line here, so like an adverse demand effect. So it's a classic supply side cost channel effect that pushes up prices but pushes down output in some extent. So that's the key empirical, or one of the third, if you want, key empirical finding we will draw from that. Again, we have a theoretical model in the background. I might skip this part now, but we are basically trying to rationalize a bit this upstream cost channel versus downstream demand story in the model, starting from a very simple, not simple, but a static multi-sector model in the spirit of the Spigula paper, for those of you who are familiar with this. And we basically augment that model with a sector-specific financing constraint, which is in the form of working capital constraint here. And then we do some comparative statics analysis to see that it's really a difference whether you vary the upstream sectors share of leverage or degree of financial constraint versus the downstream effect. And I keep that for now and for the sake of time, but come directly to the conclusion. So what do we find in the paper? What do we do first? We try to, again, decompose a bit the interaction of monetary policy with financial conditions into across the production network, taking into account the degree to what your upstream suppliers and downstream customers may be limited in their financing capacity, and how that affects the monetary policy transmission. And we find first that financial financial position overall matters for the transmission. It's overall amplifying the transmission of monetary policy. That's something other papers have shown, and we are consistent with that. But then by zooming in, we show that, first of all, these network exposures matter in total, but then also that there's a bit of a heterogeneity, whether this leverage constraint is biting, so to say, on the upstream or on the downstream of your own production chain. And then, yeah, we rationalize this in a small model, and I'll leave it with that. And happy to discuss also on the model part if there are questions on that in the discussion, of course. Thank you.
I think there's still some time left, hopefully, for 1 or 2 questions. So, anybody? Any questions? Yes, Guido, please.
Thank you. No, very good, very interesting. I have just a question that goes back to, I think, an old paper by Gilchrist and co-authors. I thought that actually they found there the effect on prices is dampened by financial frictions of tightening monetary policy shocks, right? And they were explaining why you don't have, you know, this called missing disinflation, I think.
Yeah.
So this literature instead, I mean, of course you had network and lots of other stuff. But it seems to me that you said this is, you know, known and by other papers that financial friction actually amplify the effects on the response on prices. But I thought that the Gilchrist paper was showing the opposite. Am I wrong?
No, exactly. So, I mean, of course, it's a broad, very large literature, and you're right. I mean, there are very famous papers also that show a bit of a dampening effect. I mean, here we also, I mean, one thing that we also discussed a bit in general, not discussing, I mean, there are also papers showing more amplification effects and so on, so it's a large literature. And you're right, maybe I framed it a bit like a very stylized fact everybody agrees on, probably not. But one aspect we discussed and also tried to zoom in a bit is the fact that we use also different measure for prices here, right? So it's not the consumer's prices that we look at. I mean, we have it in the data, but here we are after the sector-specific producer prices. And also my feeling is, of course, a lot of people also, especially in central banks, work on consumer prices because that's part of their mandate, but there's not so much evidence on producer prices. But what we also find in other work, policy work and so on, is that the response of producer prices is not always one-to-one mapping into what you would expect in terms of consumer prices. So that's maybe also one aspect to keep in mind that may shift the balance a bit in how you evaluate the price response. But a very good point. Thanks.
Okay, thanks a lot. Let's give an applause to all the speakers of the session. And Governor Holzmann will say a few closing words now.
Well, with this fourth presentation in the second part of today's academic session, this concludes the 52nd conference, economic conference to OeNB in cooperation with SUERF. So allow me in a few minutes to throw in some of the conclusions that I would like to share with you. There are 6, and I will even cut down a little piece that we come on time to our lunch and continue our discussion. I think the first conclusion is, and we heard it on the first day very much, but also sipping in the other areas, is that technical innovations, be it the stable coins on the one hand and being the advances in AI, are definitely factors which will alter our way how we at least process information about monetary policy, but likely it will also impact the way how monetary policy is impacted and how it may have to be changed and adjusted there. And we in the economy, at the banking, and particularly the central banks, we are only about to understand and learn what the potential implications may be. The second one, and this was a major part of our discussion, and the first policy part of it has to do with the changes between China, US, and this increase in uncertainty at the level of never seen in recent decades. And here, definitely, this uncertainty, as we have heard, is an uncertainty which strangles the economy, and the question is now what public policy and monetary policy can do about it. And the good news is that we may come up with a scenario which Daniel Gross sketched to us, that at the end of the day, if and as we succeed in, if one of the outcome is that any kind of trade tariff relationship, US-China, dominates what we are having with regards to the US and also other countries. In this case, maybe profit actually, because as he said, 85% will remain outside, and we were able there to even increase trade relationships. This may be something which doesn't lead to a worse situation, but actually a situation which is not worse than before and even better. A third part of the discussion came out is that Europe seems to fall behind the technical frontier over the last decades. And also with regards to China, we are losing against China also with regard to the mid-tech sector. And this also means that productivity is a major part of this change. And the question is to what extent productive changes should be incorporated in our monetary response function. Of course, if we build it into it, then we may have a loop, and in this case creates time inconsistency in the way how we structure it. So I think the best choice is to leave and encourage the budget sector, the industrial restructuring, the industrial policies to become active more. And 2 days ago in the evening, I had the pleasure was of opening the Schumpeter lecture. Schumpeter Prize comes in autumn there, and we had an interesting presentation there in which seems to be a new stream coming out internationally, very much also from the Anglo-Saxon part, which tries to portray that industrial policy may have and may be effective. Whether it is the case, I was a bit more skeptical, but the idea that industrial policy is well designed under this and this condition seems to be taking up again, and definitely has a bearing with regards to get rid of some of our arrears there. Point number 4 is the question that with regards to the tectonic shift we have recently seen there, what does it mean with regards to our monetary policy information, monetary policy structuring there? And definitely what has happened before before the inflation took place is that we had limited our monetary reaction function very much to thinking about what happens, what needs to happen in order to move out of the low inflation scenario. Now we had a high inflation experience more recently, so monetary policy must be designed hopefully in the future to a much larger field, and not only towards some specific scenarios which may emerge. And this also means the question then how do we review our monetary policy experiences, so the review of the monetary strategy. And here definitely, well, we have to wait what the outcome of these various countries are, but definitely, and this also came out in the discussions we had on the first day, that I think we need to be more skeptical about the use of unconventional monetary policies than we have seen so far in the empirical work there, in order to be able to prepare better for the future. Point number 5, and is a conclusion from the discussion I would draw, is that we should avoid over-activism in monetary policy in face of the short-term disturbances. And as a result, I think one of the conclusions may draw is that it will be important to keep some powers dry, as Daniel Gross has mentioned it, and perhaps be more patient to see through some of the disturbance that's coming on us. And the last conclusion, this was about this day and these great papers we heard. I think it is important to continue to have this presentation of cutting-edge research. Would have hoped to have more policymakers sitting here in order to get this great information how varied monetary policy may impact economic developments, but also to see how external effects of inflation, how varied impact it has some of the key sectors there, and the labor market papers we had today, for me, were a number of great lessons, because as we discuss in Frankfurt our preparation for monetary policy decisions, when we go through each of these sectors there, very often we come across to some of the puzzles where we have a little empirical answer, and I think there's much more answer out than I had expected. So thank you much for all this great research and the presentation. This leads me, of course, to the last part of it, thanking everybody who has contributed to this, I think, really very successful conference. Of course, primarily those who prepared the papers and speeches, thanks a lot, and thank you also to your co-authors for the work well done. And secondly, also thanking very much those who prepared the conference administratively. I think it was excellent, including the food we had received during the breaks and also yesterday evening. And last but not least, to the institutions that are behind both these conferences, both at the OeNB and at SUERF. Thank you very much for the great and consistent, outstanding work there. And I wish you all the best for the next conferences, where I sit somewhere in the back benches there. This is my last appearance in the situation. It was a great joy being here, and it was one of my highlights of my life. Thank you very much.